Dopamine that follows effort is generally good for us. One would hope that effort is in service to our own goodness and the goodness of others, but that's generally true. Large amplitude peaks in dopamine that don't require effort are dangerous. And to me, it's clear that if you care very much about your brain, that more than 2 drinks per week on a consistent basis, probably not a good idea. If you need a stimulant every time you're going to exercise, you are creating a pattern of behavior and likely some underlying neurochemical habits that are not going to serve you well in the long run.
Super excited to be sitting here with Dr. Andrew Huberman, who is a professor of neurobiology at Stanford University and a phenomenal science communicator, has the wildly popular podcast, Huberman Lab Podcast. Andrew, this has been a long time in the making. Super pumped to have you on the podcast and have this discussion with you. It's been a couple of years since we've talked. So, really excited to get into it. I mean, you've covered a lot of really interesting brain-related things in your podcast, but some of the things that have jumped out to me as very interesting is just understanding the way our dopamine system works. So I was wondering if we could kind of just start by talking about what dopamine is. A lot of people think it's just a neurotransmitter, and why it's so important for our everyday life.
Okay, happy to do that, but I'd be remiss if I didn't express a debt of gratitude. I love your podcast. I've been a fan for a very long, long time. So for me, it's a dream come true to be here as a guest on your podcast. I know you've been a guest on mine, and hopefully we'll be again in the not too distant future. And also, I want to point out what should be obvious to everybody, but in case it's not, that anytime people say, with respect to public science communication in the realm of podcasting, people will say, who was the first man in? And I say, actually, it was a woman. Her name is Rhonda Patrick. You are the first advanced degree scientist to step into the public-facing education arena and to do it in podcast format at scale with your own podcast, on Tim Ferriss's podcast, Joe Rogan's podcast, and of course, you continue to do that. So I just want to say thank you for being first one in, and just really remind people that that's the history of this whole thing. So thanks for paving the way. We all owe you. And so thank you.
Much gratitude. Thank you very much.
Yeah. Dopamine, super interesting neuromodulator. Neuromodulator, not neurotransmitter. I'm not being overly nitpicky there. The word modulator is key because if you want to understand dopamine, it's important to understand that it basically adjusts the activity of a lot of different circuits, meaning it's less involved in most cases in very local communication between neurons. It can be, than it is changing, say, how much the reward and motivation circuits are ramped up versus the circuitries in the brain that are involved in feelings of satisfaction. So you can think of dopamine, because it's a neuromodulator, as kind of generating playlists, if you will, of certain genres of neural circuit function, okay? And that's distinctly different than a neurotransmitter like glutamate or GABA, which can also do the things I just described, but are most often associated with like local communication between neurons. To use a different analogy, if we were to drop 1 million microphones into a stadium filled with people, each microphone listening to the specific conversation between 2 or 3 people, then we could say the speech between those people and what's going on there is more like what neurotransmitters are responsible for, local communication. Whereas if we were to have, let's say, 10 or 15 microphones grabbing from a bunch of different conversations and even shaping those conversations by virtue of, pinging those conversations with certain keywords like excited, motivation, et cetera. Well, that's more akin to what dopamine is doing. It's working at a broader scale to change the way that the circuitries in our brain work. So when I say neuromodulator, that's why. When it comes to understanding what dopamine does, specifically, it's important that we note that it does different things in different parts of the brain and body. So there isn't one singular function. Dopamine is, in fact, expressed in the eye. It's involved in adaptation to light. So that's a function that most people don't associate with dopamine, but it performs that role there. It modulates the activity of retinal neurons so that under different luminance conditions, brightness or darkness, the eye can still make sense of the visual world. As you go into the brain further, what you find is that dopamine is expressed in neurons that are exquisitely tied to our ability to move. Okay, most notably in a brain area called the ventral tegmentum, which just means the floor of the midbrain, which is called the substantia nigra because the neurons there are dark. And those neurons are critically important for generating smooth movements. Those are the neurons that degenerate in Parkinson's, and that's why you see a elevated resting tremor and difficulty initiating movement in people with Parkinson's. In fact, most of the treatments for Parkinson's center around trying to replace that dopamine or those dopamine neurons. And then as you move into the classic reward system of the ventral tegmental area, nucleus accumbens, these are all just names of brain areas that are associated with reward, motivation, and pursuit. And most people associate dopamine with a sense of reward. We hear about dopamine hits, the idea that, okay, I'm thirsty, I take a sip of my tea, and I get a dopamine hit. That's the idea. Now, in reality, dopamine is more closely tied to motivational states, the pursuit of rewards. And those rewards could be in the form of something that you get or a punishing thing that you remove. This is important. The removal of a painful stimulus or say, agitation or moving from a state of being too cold to being comfortable or too hot to being comfortably cool also will release dopamine. So dopamine isn't really tethered to any one thing. It's a currency that is involved in generating movement, that's not coincidental, and is involved in motivation and pursuit of particular rewards. And those rewards are contextual. In an environment where it's exceedingly cold, finding warmth is the reward. In an environment where it's exceedingly hot, you're hiking in the Joshua Tree Desert, you've run out of water and it's really, really warm, getting into that cool shower is going to feel fantastically good. And dopamine is no doubt released under both conditions, but dopamine is released en route to goals when we think, or to rewards, when we believe that we are on the right path to those goals. And this is critical, and this is why we say it's involved in motivation. There's a classic experiment that I think summarizes the specific role of dopamine and disambiguates it from the reward properties of dopamine, because it does have reward properties, best. And the experiment is essentially the following. You take two groups of rats. One group of rats has an intact dopamine system. The neurons are alive and thriving in this reward system and other areas of the brain. And you give them access to a lever press or some other small amount of work that then generates a food reward, like a Fruit Loop or something. Rats and mice love these kinds of things, as we know, as do humans for all the wrong reasons, but real ones nonetheless. Those animals will work. They'll lever press. They'll even work through a maze. They'll do a number of different things. Some will even cross a shock plate to get to food if they're hungry enough. And the intact dopamine system helps them do that. It's motivation-based reward pursuit. A second group of rats has a specific category of dopamine neurons ablated, neurochemically ablated, and that particular category of neurons are the neurons that are responsible for what we classically think of as reward, this ventral tegmental nucleus accumbens pathway that we can talk about. And those animals will not motivate to get the reward. However, if the reward is accessible to them, they'll eat those Fruit Loops all day. In other words, it appears that dopamine is required not for the sense of pleasure or reward, not for the reinforcing properties of food or other reinforcers, warmth when it's cold, cool when it's too hot, etc., but rather the desire and especially the ability to convert desire into a physical movement, or in some cases, a cognitive movement. We could talk about what that would look like, cognitive effort, to reach a particular goal. So what that experiment illustrates, and by the way, this has been observed in a naturalistic type experiment where people with Parkinson's have fewer dopamine neurons, not just in substantia nigra, but elsewhere, as evidence that dopamine is most critically involved in motivation and pursuit of goals, not pleasure itself.
So you've talked a lot about this dopamine wave pool and understanding like how our dopamine levels are fluctuating throughout the day. So this dopamine dynamics. Can you talk a little bit about that, like the peaks and the troughs and our baseline levels and how that does influence our motivation for pursuing goals or in some cases maybe rewards in general, and how that just affects our performance.
Absolutely. So before I do, I'll just mention that the dopamine wave pool analogy is one that I borrowed from Dr. Kyle Gillette, who's a medical doctor who's been on my podcast and focuses mainly on things related to obesity and hormone stuff. He was the one that initially coined that phrase. I like it very much because it embodies a number of key features of the dopamine circuitry at large, not just one circuit, but how dopamine works generally, psychologically and physiologically. It's the following. First of all, dopamine is a depletable but replenishable resource. In other words, unless the dopamine neurons are destroyed, like in a case like Parkinson's, or rare, exposure to neurochemicals that are involved in, certain pesticides, and that's not a dig on certain pesticides per se, but there's a history there of people, taking certain compounds in and destruction of dopamine neurons. Those particular cases aside, most of us have dopamine neurons that can readily release dopamine and do so at what I would call a tonic level. It's kind of what we could just refer to as a baseline level of dopamine neurons firing in the background, tick, 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 just firing off action potentials, electrical signals, releasing dopamine into the various circuits that they're trying to modulate. Then there are what we can call, for sake of this conversation, dopamine peaks and dopamine troughs, which are increases in dopamine release that ride on top of that baseline and that influence that baseline. Let's go back to the wave pool. In the wave pool analogy, you start with a certain amount of water in this wave pool, and then you start generating waves of different amplitudes. If the waves are of a particular size, well, then they rise and subside, and you don't actually deplete the total amount of water in this pool. Okay, the baseline level doesn't change despite the fact that you have these peaks and troughs. If you get enough movement in that pool, you get big waves, some starts to splash out and the total amount drops. In other words, the baseline level of dopamine has dropped, or in this analogy, it's dropped. So I like the wave pool analogy because even though it doesn't embody all of the dynamics of dopamine, it embodies many of them that we can relate to. For instance, if we take the extremes of things that cause massive amounts of dopamine release. These are typically illicit drugs, things like methamphetamine, 1,000-fold increase in dopamine release. Cocaine, the combination of different highly reinforcing dopamine-related activities or drugs. So methamphetamine plus sex, right? This is common in certain addictions, right? People will take stimulants like methamphetamine. They will also engage in sexual activity. Now you're getting way up past 1,000. It's not always additive, but it often can be additive or even synergistic. What happens under those conditions? Well, neurons in the, let's just call it the motivation and reward pathway, are releasing massive amounts of dopamine, sometimes to the extent that the readily releasable pool of vesicles, or sometimes called vesicles in the US, of the little spheres filled with neuromodulator, dopamine, actually get depleted. And the neurons need to manufacture more, and that takes time before more can be created. There can also be neurotoxicity where the neurons actually are killed off, although that's in more extreme cases. So what we're talking about here are drugs of abuse like methamphetamine, cocaine, combination of dopamine-releasing activities, sometimes drugs, sometimes sex, sometimes video games in excess, plus maybe compounds like Adderall, Vyvanse, et cetera, which clearly increase dopamine release. And then what happens is some hours later or days later, depending on the frequency of the activity, the reservoir, the pool, is essentially lowered its overall level. So now in order to generate waves of equivalent size or even smaller size, you need a lot more, let's say, movement. What is that movement? Well, typically that's the pursuit of more reinforcing stimuli. But guess what? With dopamine depleted, that becomes harder to generate. And so hopefully I've created a picture here. This is obviously a kind of cartoon picture of dopamine dynamics. It's not quantitative in any way. But what it essentially says is big dopamine peaks lead to lots of dopamine release. And then what we know is that the dopamine levels that follow those peaks drop below baseline. And if the peaks are high enough, they will deplete that baseline. But remember, we said that the dopamine pool is depletable but replenishable. How is it replenishable? With time and with either lower or no dopamine peaks. So if we step back from real life and we look at it and we can say, okay, if I pick up my phone and I'm scrolling on Instagram, highly reinforcing behavior. I mean, videos and images are so powerful to us. I mean, a few years ago, there was a hack that I think Tim Ferriss put out on his podcast. If you shift your phone to black and white mode, grayscale, I mean, all that stuff becomes far less reinforcing. You kind of don't want to look at the thing. You shift it back to full color, and it's like, whoa, it's just so much more compelling. So you're scrolling, you're seeing things. And yeah, if you see something that you really, really like, maybe an animal video that you really like, in my case, then sure, there's very likely to be some dopamine release. Is it going to deplete the baseline of dopamine? Unlikely, but if you engage in that activity for many, many hours, you could imagine that it might. We don't have exact data on this. Certainly, if you're combining any kind of stimulants that tap into the dopamine system, this is going to happen. Certainly, if you're engaging in drugs of abuse or just a lot of, exciting high amplitude activity, it makes other things seem more boring because actually relative to what was going on neurochemically, it is more boring. The brain doesn't have a sense of exciting and boring. It doesn't have a sense of motivated, amotivated in the subjective sense. It has a correlation between the activity of these dopamine circuits and other circuits, but certainly these dopamine circuits, and some subjective feeling of either desire to engage, aka movement, or lack of desire to engage, such as, just kind of apathy and just feeling like, hey, there's nothing here for me, but here I am continuing to engage in this activity over and over. And we know that with most all drugs of abuse, but certainly with anything that releases dopamine, there's nothing quite like the first time. And that these circuits actually learn. They can become reinforced in the sense that they build up strength between particular synapses and things of that sort, so that we continue to, in a seemingly logical way, go back to the original behaviors, trying again and again, hitting that lever, trying to get back to that similar state. And just like a slot machine, every once in a while, we get what we're looking for, and the whole thing is further reinforced. Now, that's all painting a very sinister and kind of dark image of the dopamine system. And I want to be clear that this wave pool analogy doesn't have any valence to it, positive or negative. It's just one analogy for how the system works. In a different frame, if you understand that you have some baseline level of motivation, desire to move cognitively, physically, and you understand a bit about how these dopamine peaks and troughs work, well, then you can work with it. I believe you actually can leverage it so that things like procrastination become less likely, so that you can engage in social media in a meaningful and positive way, but then know, okay, I'm going to put it away now, and I'm going to take some of that elevated arousal that I feel and put it towards some other, enriching activities. There's nothing good or bad about dopamine, and we shouldn't fear it. It's really about understanding the underlying dynamics, and that if we've taken ourselves to a place where we are just depleted, where that baseline, the level of water in that wave pool is way down because we've had these huge waves, well, then we need to be patient. We just need to wait and expect that at some point pleasure and motivation will return, but that we need to wait a period of time as opposed to what most people do, which is to go pursue things to get them out of that somewhat subdued state.
So I have a few questions. First of all, a big thanks to Dr. Gillette for that amazing analogy. I love it too. It really makes it a lot easier to understand how this dopamine system's like working in a general sense, at least. Maintaining the steady baseline levels, it sounded like it's not so easy to deplete the baseline unless you're really going after something that's either a substance that could really sort of increase your dopamine in combination maybe with other enjoyable things as well. It is the effort that you're putting in, so like you are preparing for a long-term, like let's say you're preparing for a wedding or something big or a party, and you put in all this effort and planning, for a month, and then you have the party and it's fun. It's great. Everyone has a great time. It's a fun party. And the party's over. And then you feel kind of depressed. Like, can you deplete your baseline levels just from like putting in like having an event like that? Or is that effort that I put in kind of going to shield me from the drop in those baseline levels?
Yeah, well, the simple answer is the latter, that dopamine that follows effort is generally good for us. One would hope that effort is in service to our own goodness and the goodness of others, but that's generally true. Large amplitude peaks in dopamine that don't require effort are dangerous. Drugs of abuse do this. One pill, one shot and you've got 1,000-fold increase in dopamine release, that's scary, because that's not the way the system was designed to work under normal conditions, right? These are drugs that sure might, mimic certain compounds in nature, but let's face it, these circuits that we're talking about evolved for the pursuit of particular rewarding activities, mainly centered around food and reproduction, okay, and keeping us safe, avoiding extremes of temperature, et cetera. So I think the critical thing is that, well, in the example you gave, a lot of effort put toward planning a wedding and then hopefully a wonderful wedding. That is all goodness. That is all goodness in the sense that there's going to be dopamine released as one is making plans, see the invitations, you like the invitations, maybe there's a dispute, you resolve the dispute, which, by the way, remember the removal of a negative stimulus, also dopamine, great, we're back on track, we're doing all this, and then wedding goes fantastically well, maybe one glitch, okay, great, and you have the photos and the memories, all of that is great. If the next day or in the days following people feel a bit of a low, a bit of a postpartum type low, that could be related to a drop in the dopamine level. More likely it's fatigue. It's also anticipation itself breeds this own kind of letdown once something follows. I mean, this is the nature of, true clinical postpartum depression where, post-childbirth, this is a real clinical syndrome, as we know, that sometimes people deal with, unfortunately. It needs to be taken really seriously. But in the kind of more popular use of the word postpartum depression where, post-wedding, post-graduation, it's the shift in arousal state from anticipation and higher arousal, what's next, I'm excited about what's next, what's going to happen, to I don't know what's going to happen, what now? It's the what now kind of circuitry. So I think that when it comes to understanding one's own dopamine system, there are a couple things to pay attention to. First of all, we all wake up in the morning, depending on how we slept, but let's assume our typical good night's sleep for us. I need 7 hours, some other people need 8 hours, others 9. What is your level of positive anticipation about things to come, even if those are deadlines or things that you might not want to do so much? How much get up and go do you have, right? I move a bit slowly in the morning, but once you're fully alert, how much get up and go do you have? One of the classic signs of depression is early morning waking. That's one. The other is a lack of positive anticipation about future events. It's a classic depression symptom. The dopamine system might be involved in either or both cases, but what is the sort of classic representation of a positive, highly motivated person? It's somebody who is eager to move, like the ability and the desire to move into action. I borrowed this from a friend who was a former SEAL team guy. He always said, in everything in life, you can either be back on your heels, flat-footed, or forward center of mass. How much forward center of mass, how much Goggins do you have in you, or Jocko do you have in you, or Rhonda do you have in you at any given moment? Or Rogan too. These, you all seem to have so much motivation, and I know that's why many people are inspired to pay attention to the things you say. It's also the underlying spirit of pursuit. It's exciting to us. Other people have more of a kind of lay back and observe mannerism. And I do believe that they too could have perfectly fine levels of dopamine. They're just more observant in the way they take in life. And which is not to say any of the other people I just mentioned are not observant, but there's this business of cognitive movement, or this phenomenon of cognitive movement, where we aren't necessarily in movement in our bodies, but we are reading voraciously. We are thinking voraciously. We are deconstructing ideas and being reflective. All of those patterns of what I'm calling movement, cognitive or physical, reflect underlying firing off of dopamine neurons. It's when we have a goal in the short or long term and we are focused on that goal that the dopamine system really becomes active to generate these big peaks. Okay, it's this, I'm going to get, the company's going to IPO, or if people post on Instagram and they start getting a lot of positive feedback, like one of their clips happens to go viral or something in a positive way, it's like, whoa, it's this thing like, oh my God, it's like raining down on them, or from within them rather, in the same way that the slot machine and, in Vegas, it's, the bells are going off and you hear the coins just dropping, ting, 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 ting. There's all this excitement about here it comes the rewards, here comes the rewards. That process, as I mentioned before, is not just quote unquote rewarding, it reinforces the circuitry that led to that behavior in a very powerful way. It actually strengthens through neuroplasticity. It strengthens the very underlying circuits. And the brain is either conscious or unconsciously or both will go back and repeat that behavior over and over again in order to try and get back there, even if we're not aware that we're doing it. And so what I find so interesting about the dopamine system is that it can create its own plasticity, feedback form plasticity. Okay, there are a number of different specific cellular events that underlie that. But what it's essentially trying to do is know where the water is, where the mates are, where the warm locations are for when we're too cool, and where the cool locations are from when we're too warm. It's learning all that, but less than recording the specific locations like the hippocampus would or place that into the cortex. It's trying to remember the algorithms that led to specific patterns of mental or physical movement that allowed that. So if we step back, I hate to beat up on social media because you and I both teach on social media, and I love social media. It has to be, controlled, but I love it. But if we engage in social media and we get some positive feedback, we've reinforced at an unconscious level all sorts of circuitries that lead us to think, oh yeah, I posted that this one time, and I remember that was a text post. The other one was a slide. That was a video. And your brain is trying to learn the patterns that got you where you were before, and it worked out so well. So the dopamine system can learn. The dopamine system can adjust its baseline. The dopamine system can create these peaks. And then we shouldn't forget about the anticipation aspect of it itself, which is what's called reward prediction error. These are classic experiments where essentially it was discovered that dopamine is being released en route to a reward while a monkey or human is working for a reward. And that itself was a cool discovery. It was like, wow, dopamine isn't just, when the monkey gets the juice or when the person gets the monetary reward. It's when they think they're on the right path or they might get a reward. That's when dopamine's released. Then they get the reward. If the reward is equal to or in excess of what they anticipated, boom, they get a bit more dopamine. What better way to reinforce a behavior at the neural level? But if the reward is less exciting or less money or less intense than one anticipates, what happens? Dopamine levels drop, and then they drop below baseline when they are on their way to eventually returning to baseline. And the duration of that drop is proportional to how high the peak was. So it's like you can imagine, planning the wedding, plenty of dopamine, and then a rainy day, thunderstorm. Oh goodness. Well, hopefully people are adaptable and they adjust to that. But it's such a bigger letdown if you put in all this effort. It's such a bigger letdown if you thought it was going to be great because, well, the peak was bigger, or the sort of slope rather was steeper, and the slope of the decline of dopamine is also going to be steeper. So not all of this works out to perfect math when it comes to the dynamics of dopamine, but by and large, dopamine reward prediction error says if you think something's going to be great, it better be that great or greater to reinforce the behaviors that came first. If you think something's going to be great and it's less great or not great at all or even punishing, well then it's going to send signals to alter the circuitry in a way that says, whatever you did to get there, don't do it again. It's going to discourage you.
You talked about people that have this sort of intrinsic motivation, right? Where it's like they're motivated to do, they have that maybe even just initial motivation, and then they have that intrinsic motivation to sort of carry it through that effort. Can you talk a little bit about the differences between the motivation and effort? I often, it's very easy to confuse them, but some people have a really hard time, even if they want to do something, I want to do this thing, but I just can't put that cognitive effort in to do it. Are there any little, ways that people can, using the understanding of this dopamine system, help themselves to kind of push through and put that effort in?
Yeah, great question. And it starts to get a little bit complex in ways that make it hard for me to tack, specific cellular phenomenon too, but I'll do my best. So dopamine is one of the catecholamines. It's part of a group of cousin molecules. Dopamine being one, epinephrine, also called adrenaline, and norepinephrine, also called noradrenaline. These are released both in the brain and body from the adrenals, in the case of norepinephrine, from a brain area called the locus ceruleus, which releases norepinephrine in kind of a sprinkler-like manner into the brain, although it can direct the release of norepinephrine as well. And of course, all of this stuff is active and released from neurons in our body as well. It's not a coincidence. It can't be a coincidence that these three neurochemicals, which by the way are very similar to one another and actually are manufactured from one another biochemically. It's very interesting. People can go look up, how is epinephrine made? How is dopamine made? And you'll see that the molecules are actually made essentially from each other. They're cleaved by enzymes and there's various changes there. But they work together to create motivation and to heighten focus in the case of norepinephrine and epinephrine. In fact, these are the same neurochemicals that cause the changes in our pupil size under constant illumination to change the optics of our eyes so that we narrow our visual focus. Like people have heard, for instance, if your pupils get really big, right, that's a state of underlying autonomic arousal that leads to a narrower visual window and a heightened focus. Okay, whereas a shrinking of the pupils causes something quite different. Norepinephrine, epinephrine, and dopamine are involved in all of that, and that's not a coincidence. At the same time, and I'll answer your question directly in a moment, but you said some people tend to be highly motivated. I'd be curious to run an experiment. I haven't run this experiment, but some people have kind of a resting bounce to them. They have it looks like they're ready to go. Like they're just like excited, they're ready to go. Other people have a kind of what looks to be a more lethargic stance. They're more still. That can be a bit misleading because sometimes they're very active inside, still waters run deep kind of thing. But it is interesting that some people are very, you say, hey, should we head out? And they go, yeah, let's go. And they just sort of pop out of their seat. Other people are kind of like, and this is independent of how tired or alert we are kind of thing. So I think people idle at different RPM. I've noticed that. Certainly different dog breeds do that. They've been bred for that. I had a bulldog, low RPM, very low RPM. We also had a pit bull years ago. Tail was always going, higher RPM, more likely to engage in spontaneous movement. People are like that too. Okay, so if people lack motivation, does that reflect some deficit in the dopamine system? Sometimes yes, sometimes no. What we know is that many people have a hard time initiating movement. Remember that in the Parkinson's patient, it's not just resting tremor that they have, lack of smooth movements, motor movements. They also have a lot of difficulty initiating movement. Okay, so this is in the neurons that control movement, but it's a similar thing in the motivation realm. This is why I keep drawing this parallel between physical movement and mental movement. We don't really have a better language for it, at least not that I'm aware of. But mental movement is the motivation to open a book and start reading with a high degree of focus to take in that information, as opposed to, kind of opening it and like, I don't want to do this, or, just kind of not necessarily apathy, but challenges and leaning into mental effort. The two things, meaning movement and cognitive movement or pursuit, are both governed by the same neurochemical systems, these three catecholamines, mainly dopamine, with the norepinephrine and epinephrine being involved in generating focus. Other systems involved too, of course, but this is still true. So for people that have a hard time getting motivated, if we just make it that simple, assuming there isn't some major underlying neurochemical or life situation issue, oftentimes it's a lot like exercise. You've probably experienced this, that once you get going, and once, in fact, if people accept that there's going to be a transition phase of maybe 5 to 10 minutes to get the relevant circuits going for focus and for motivation, things often get much better very quickly. Now, this is a real problem where we live in a world where we can go on YouTube instantly and sort of get something right away. Again, you get a feedback or activation of these circuits for getting information with essentially no effort. It's a click. You just have to listen. I remember a few years back hearing that it wasn't going to be long before people would generally have 2 screens in front of them most of the time. And I notice nowadays I've got 2 phones and often a computer, and then screens everywhere. Most people are dealing with at least 1 screen all the time, often multiple screens. So easy to get information. Now, if you want to sit down and read a book or listen to an audiobook with a high degree of attention, I think if you're somebody that doesn't get engaged quickly into things, telling yourself the truth, which is that this dopamine system and the associated other catecholamines take some time to get online for those circuits to start firing, can be very helpful. People can realize, my attention and focus isn't going to be great for the first 5 or 10 minutes. In fact, it might feel like it's a bit of a kind of like there's some friction there. I feel like maybe I have brain fog or something like that. But after a few minutes, people often will drop into a groove where then they're in a steady pursuit of information. And then sometimes it's actually hard for them to transition out of it. In the same way, exercise, some people you say, hey, let's go out for a hike, and like, let's do it. Other people, you need to get into a rhythm. You need to start activating those circuits in order to feel like you can be in that forward center of mass. I almost always feel this about running. For the first 10 minutes, I'm like, this sucks. It's not that I'm not warmed up. Something's not warmed up in my mind. And then it starts to feel better and better and better. And then I feel like I could run all day. So, I'm using loose analogies here, but also real life examples to explain that the circuits that are responsible for motivation, for effort in the movement system and in the cognitive space are similar, different circuits, but they're also similar to the extent that sometimes they need warming up. And that will likely be more and more the case if we are engaging in activities in the rest of our life where we can get what we're looking for without any effort at all. We are, and I'm not blaming social media or YouTube. I love YouTube. We're on YouTube. You're on YouTube. But we live in a world now where our brain has learned we can get things in an instant. It doesn't require effort. And so there's been a learning of that as well. There's this, where's the reward? Where's the reward? Where's the milestone that I'm on the right path? Well, it's not there as you crack open the book because your circuits have essentially been trained to have that just delivered to you in video form. I mean, reading words on a page, I love reading, but to your brain, it's far more boring than watching a movie. Nothing, a picture is worth 1,000 words and a movie is worth 1 billion pictures, right? It's just the brain loves motion. It loves visual motion. It loves visual motion with color. It loves faces. It loves those dynamics. And so we should not be surprised at all that when we tell our kids or we ask ourselves to sit down and read something, we go, oh my goodness, what's going on with me? Give it a little bit of time, 5 to 10 minutes, and understand that you're asking something very different of your brain under those conditions. Now, if you get a text message from somebody and you're anticipating that text message, what's the diagnosis? Did you win this? Are you going to see them and you're excited? Well, then you're going to be wrapped with attention. But again, text messages are this instant form of communication that, both taps into, no doubt, the dopamine system, the anticipation system. But I think what I'm saying here is that a lot of the typical daily activities that we engage in and that we all love are actually training our circuits to be less effective at working through that initial friction.
Less effort. I've heard you talk about attaching the reward to the effort itself and how that can help you in your system sort of value more the effort, right, rather than the end reward.
Yeah.
Do you have some examples of how would you attach a reward to the effort itself?
Okay, so there's the psychology and then there's the physiology. The idea of attaching reward to the effort process itself is kind of the holy grail of learning anything and being human, in my opinion. And here we can look to the beautiful work by my colleague Carol Dweck on growth mindset. This notion of attaching the word yet, that somebody isn't good at something and they can tell themselves yet, that they can be, that there's a capacity for growth and so on. There's also the beautiful work of another colleague of mine, Dr. Aaliyah Crum at Stanford, and David Yeager, who's down at University of Texas, Austin, which has combined a lot of the discoveries about growth mindset with the stress can be performance enhancing mindset, and to great success, in my opinion, in terms of cultivating better academic skills and so on. So we'll get to that in a moment. But the idea here is that the dopamine system, even though it's down in the midbrain and it's involved with, and it's also, communicating with the striatum and it's communicating down to the spinal cord and it's involved in all this stuff that's evolutionarily pretty old, right? Reward mechanisms and movement exist in other animals too. But the amazing thing about these pathways is that they are highly subject to context-dependent learning. So the prefrontal cortex, the neural real estate behind our forehead, it's a bunch of different areas of the prefrontal cortex, but it's essentially a context learning machine. It learns what's appropriate in one situation and not another, and it learns rules. It can teach and learn rules. But it doesn't just teach and learn rules to you. The circuits involved in motivation and reward can learn those rules. Even so far as to say accurately that if you are in a process of trying to learn something and you can't do it, you're like, I can't figure this out. But you have the knowledge, the cognitive knowledge that that feeling of what I call limbic friction, I made that term up, but this feeling of friction, like this is tough, this is agitating, I can't do it. If you are aware of the reality, which is that reflects the release of neurochemicals involved in attention and alertness, and it's changed the milieu of your brain to allow plasticity to occur, then you can tell yourselves in those moments, the challenge that I'm experiencing right now is the gate to neuroplasticity, which it is. It's a way that my brain knows this is different than everyday life because I can't do what I'm trying to do. Pay attention, do something differently, keep drilling. And that process, if you tell yourself the simple, self-talk of I'm on the right path, the fact that it's difficult means I'm on the right path as opposed to the wrong path. What that means is that the dopamine system can start to recognize those general themes of thinking, general themes of internal arousal state in the body and brain, so that in the future, when you encounter those states, this is good. This is good for me. In other words, it's not just that the dopamine is released when we are in pursuit of heat, when it's cold, cool when we're too hot, food, sex, etc. The dopamine system can also learn based on knowledge that we are told and that we believe. And there's actually a beautiful paper in Neuron published a few years ago that actually attaches beliefs to the dopamine system. It can get a little scary because what it essentially showed was that people who get confirmation of their pre-existing beliefs get dopamine release under those conditions. This explains a lot of what we see out in the world, both online and elsewhere. But the important point here is that what we believe about how dopamine works, what we believe about effort, those things can be merged in a way that indeed we can start to attach reward to the effort process itself. As we are striving, as we are trying to go from flat-footed to forward center of mass, if you will, or from back on our heels to flat-footed to forward center of mass, as we're doing that, if we tell ourselves, okay, this is supposed to be painful, hopefully in a non-traumatic, non-physically or psychologically traumatic way, but that I'm doing this, this is it. This horrible day that was so difficult, this is part of growth. This is part of I'm on the growth curve. That knowledge can shape and will shape the neural circuitry associated with dopamine and reward so that in the future, when you encounter it, it's like, oh yeah, this is how this works. And, people hear this and they go, well, wait, how do I do that? How many times do I have to tell myself I got it right? There hasn't been a deep exploration of that, but everything we know about the psychology of growth mindset, and then I mentioned the stresses enhancing mindset, it's worth just noting the stresses performance enhancing mindset is one in which it's beautiful experiments where people watch a movie about how stress diminishes performance, causes challenges in immune system function, et cetera, et cetera. It's all true. A different group watches a video about how stress can enhance performance, sharpens focus, sharpens memory for specific things, et cetera, and it improves performance. So what it basically boils down to is that what you believe about a certain state in your brain and body has very much to do with how your dopamine and other neurochemical systems react, and that carries forward into other activities. That's why I love so much about the dopamine system or these other systems is that they generalize. Dopamine is the currency for all of this. There are other currencies in there too. I want to be fair to the biology, but dopamine is the currency of motivation, reward, and pursuit, but mostly motivation and effort. And then additionally reward under certain conditions. So I guess if that was too word dense, when things get hard, tell yourself the fact that they're hard means you're on the right path. You might not be on the exact right path, but think of yourself as cutting a wedge through a map to get to a certain destination. Sure, as you gain more knowledge of right and wrong aspects of your pursuit, you can sharpen up or narrow up that wedge so that you nail the location like a Google Maps trajectory. But understanding that as you are in pursuit, you are tapping into the dopamine system. Now, if you hit a node, if you will, in your pursuit, and it's like, oh, you got the wrong thing. It was like you didn't meet the goal. It didn't go the way you wanted. It's also useful to understand that is valuable knowledge. The lack of reward, the disappointment you feel, will also reinforce not doing many of the things that led up to that. We just have to be careful that we don't generalize too much, right? There were exams that I studied for in university that I didn't do as well as I would have liked. In fact, one course in particular, and I still remember the course, and I still remember exactly what went wrong, but that's exactly the point. We have a heightened memory for where effort led to the thing we didn't want. And we can use that to make sure that we remember that information going forward. We apply that information going forward. In fact, as you know, in a qualifying exam, they keep asking the graduate student questions until you say what? Until you say, I don't know. And at that point, they've found your limit. And the answer to that question, inevitably, people go look up. And it's the one thing from your qualifying exam that you never forget. So in any case, that's the best sort of topical description I can provide.
And some of it really sounds very much like the placebo effect too, right? I mean, the placebo effect where you believe something is, going to be positive, it's going to happen. And I believe you also release dopamine, right?
Absolutely.
So, I mean...
placebo effect is amazing.
Right.
I mean, and scares certain people, but I don't think it should. I think that we should look at the placebo effect as proof positive that the circuitries in the brain that are involved in primitive things, dopamine release, temperature regulation, hunger, et cetera, are highly prone to contextual learning. This drink is going to do blank, and it does. Give someone else the same drink. Again, Aaliyah Crumb's work, give the milkshake study, right? Give people a milkshake, tell them it's high calorie, or tell them it's very nutrient dense. You get more satiety than if you tell them it's nutrient sparse.
Right.
I mean, it's just and it's the same calorie drink. But you can look at the level of ghrelin secretion and see that is pure placebo/belief effect.
And I think that makes sense if you are in the middle, like if you're wanting to reward effort, then while you're in that, when you're doing it, when you're in the effort part where you're like in motion, right? Mm-hmm. Then thinking about like, this is working, like this is like, then there's the dopamine, right? Attached to the effort.
That's right.
I mean, am I thinking about it right?
Absolutely right. You described it far better and more succinctly than I ever could. It's important to pay attention to what effort feels like in the brain and body and to remind ourselves in those moments, I'm on the right path. I might not be on the exact right path, but I'm headed in the right direction. And sure enough, when you hit a milestone, whatever that milestone is, you should pay attention to that milestone, the reward, the grade, et cetera. I'm a big believer of also sometimes not paying too much attention to that. I'll never forget in graduate school, we got our first paper published, and I thought we would go celebrate. And I asked my PI, my lab head, I said, are we going to celebrate? And she said, I don't know, wasn't the celebration doing the experiments? I was like, well, those were a lot of fun, yeah. And she said, well, I guess we could get a pizza or something, but how about just go do more experiments? And so that's what I did. And at the time, I remember thinking, oh, that's no fun. But she had a long commute home, and maybe who knows, she didn't have the time. But looking back, it's like, what a great gift. Because it was like, no, it was the doing of the experiments that was the reward. The paper, yeah, that's super cool. It's fun. First paper is always a thrill. But no, the real thrill is in doing the experiments, doing science. And so let's not introduce anything to this picture that doesn't map onto that. And I don't know to what degree it played a role in my pursuit of goals, but I really enjoy effort. In fact, I love building stuff as much or more than I do indulging in the final product.
And you do an excellent job. I guess as a parent, if you're trying to attach a reward to effort to kind of help facilitate tenacity, willpower, like if a child, like you're not going to be able to tell a child to do what we were just talking about, but like if a child was like learning a new language, then you would reward the studying time, right? Like, so it's like they're studying, okay, every study session they get a quarter or whatever. Like, so then they're like rewarded for studying, not for like the fact that they can say the words properly or, get the language correct or whatever. So
exactly. Reward verbs and verb states as opposed to providing adjectives. So when we tell kids, you're so smart, we think we're doing a great job of reinforcing their psychology. But actually what a lot of data, not all data to be fair, but what a lot of data show is that leads to a state where if that kid or adult gets something wrong, then what's the opposite of smart? They think they're stupid. Whereas if you reward, it's incredible, and I'm so impressed by the effort you put in, how hard you worked, the fact that you really double checked everything before turning in your paper. The fact that you were really, I noticed how carefully you blanked, right? You went through each thing, and you're also reinforcing specific things that they can repeat. Just telling a kid that they're smart, and they go through life thinking they're smart. Well, the first time, and listen, it's going to happen sooner or later. The first time they get evidence to the contrary, they just take the opposite of that. So much so that I remember also my graduate advisor saying, with students, you want to say, what was it? Instead of be careful, be mindful or something. Like there was this idea that, trying to get students to pay attention to things in a certain way, as opposed to rewarding people based on bins, like, smart or less smart or something like that. So with kids, I think rewarding and reinforcing verb states that led to the sort of categorization is what's going to be most effective. At least that's what the data show.
Yeah. Going back to procrastination, I've heard you talk about some interesting visualization, techniques where, if a person's in a state of mind where they're yes, they want to do this goal, this, whatever the fill in the blank project is or goal, then, they can use a visualization technique. But if they were not, they could also do something, but they could use the pain and discomfort to help themselves get into that, actually do it. Can you talk a little bit about that?
Yeah, Tim Ferriss was right with fear setting. So there's a really fantastic scientist, professor at NYU, Emily Balcetis, who talked about this and continues to research it, which is that oftentimes fearing the worst or feeling negative outcomes, if we don't do something, can be very beneficial as a motivator. So that's not to say, fearing the worst case outcome. It's placing some real time on fearing the negative thing that happens if we don't do something. Okay, so that's kind of unique to that case, as I understand it. Visualization of positive outcomes is great as a motivator, but there are data that suggest that it might not sustain motivation over time. I think it's probably fair to say that having both in your toolkit is great. Visualizing success can be useful in some contexts. Visualizing the negative effects of not staying in pursuit of a goal also can be very motivating. That's essentially what the data show. Now, when it comes to the underlying circuitry and what's going on in the brain, that's a little bit harder to know. But what we do know is that the pain system and so-called negative reinforcement and punishment, the psychologists really parse these carefully, so I want to acknowledge that I'm not using the exact operational definitions here, that the dopamine system, as I mentioned earlier, is also very tightly woven to avoiding punishment, to escaping punishment, to being under conditions of discomfort and then no longer being under conditions of discomfort. So we could hypothesize, or we don't know, but we could hypothesize that, for instance, if you imagine, goodness, if I don't do this, a bunch of negative things are going to happen. And that itself could trigger a certain form of internal arousal that would put you into motion for that. And that whole process would be rewarding. So that makes logical sense, at least, in its kind of top contour, it makes logical sense. The other thing is that if we try and think about ways that we can avoid procrastination, we can go back to the dopamine wave pool, baseline peaks, troughs, and return to baseline kind of stuff that we were talking about earlier. And there's some interesting ideas out there and data, although right now it's still being sculpted out in humans, meaning the experiments are still underway. It's a little bit tougher to do in a scanner to get at exact mechanisms. But I think there's enough logical basis and mechanism to propose the following, which is that if there's something you need to do, that you need to do, but that you're finding yourself very unmotivated to do, it can be useful to do something even more uncomfortable than waiting and procrastinating. I didn't say even more uncomfortable than the thing. I said even more uncomfortable than the thing that you happen to be doing at the moment, which is just waiting and procrastinating. So what would that be? Well, we've all seen the opposite, where we have a deadline and suddenly we find ourselves cleaning our home. We find ourselves doing these things that are kind of low-level effort that, for whatever reason, if you think about it, it's kind of wild. We weren't motivated enough to do a day before, an hour before, but suddenly we're motivated. It's almost as if the motivation circuits are sort of getting ramped up, trying to figure out what to direct it toward. But clearly, that's easier than focusing and directing one's effort toward the deadline, toward the cognitive or physical effort of something else. So there's this idea that many people have put to good use. Go do something that's really uncomfortable. Again, don't make it psychologically or physically traumatic. But if you really don't want to exercise in that moment, that'd be a great moment to exercise, to engage those circuits. Remember, it's a generic circuit. There isn't a circuit for motivation for one thing versus a circuit for motivation for another. It's all just the general same circuitry is applied to different things. So I happen to hate the cold. I don't like doing cold. I love the sauna, I hate the cold. So for me, getting in the cold plunge anytime ever, unless I'm getting out of a very hot sauna and I want cold, is like the least exciting thing to me and the thing I'd like to avoid most. So if I'm finding myself in a state of procrastination, so some writing, some whatever, posting, researching, etc., I will often do the cold plunge as a motivator. Now, we need to be fair to the biology and acknowledge that when we get into uncomfortably cold water, the catecholamines are released: dopamine, epinephrine, norepinephrine. We know that. There's this beautiful study in European Journal of Physiology. You know far more about this work than I do, but I've spent some time with that paper, and there's a pretty remarkable and significant long-lasting increase in the three catecholamines: dopamine, epinephrine, and norepinephrine. So we can't know that it was the discomfort of being in the cold plunge itself that led to more motivation. It could be the discomfort led to the release of these catecholamines, which led to a different brain state, which allowed for more pursuit of whatever this other task that one was procrastinating on. But I think it's reasonable to assume that all of that stuff together had a significant effect. Okay, we're not talking statistically significant. This study hasn't been done yet about evaluating procrastination versus cold plunge versus no cold plunge. That'd be an interesting study. But the point is the same three catecholamines involved. The discomfort of one thing leading to the post-discomfort state of less discomfort, but elevated catecholamines bringing one into a state of more motivation. To me, it makes perfect sense. Like, it all holds up logically. And why cold? Well, cold is always, provided it's uncomfortable but safe, uncomfortable but safe cold water exposure always deploys these catecholamines. Is sort of a core part of our physiology. There are probably other ways to do it: exercise, et cetera.
Exercise hard.
Exercise hard.
Because like going on a zone 2 run is not like that uncomfortable.
No,
I think like
zone 2 is a cakewalk.
But going hard,
right.
Doing a hard hit,
right,
is. I don't want to do it, but yeah,
the assault
where
bike. I do a Friday workout. For me, it falls on Friday, where it sounds so easy, but it always sucks to start it. 10 seconds hard pedaling on the assault bike, 20 seconds rest, 10 seconds on, 20 seconds off, and just do that 8 times. Just get my heart rate just way up once a week. I never want to do it. And then afterwards, you always feel terrific for many hours. It's wild.
Yeah.
And it has to be the catecholamines.
I definitely want to go into a little bit more on exercise and cold exposure and dopamine. So kind of, I guess if I'm understanding this correctly, really like there's something about doing and embracing something that's more uncomfortable to you than just, I guess, sitting and waiting and then you do it. And let's forget the fact that cold plunge also releases dopamine, but let's say you do it. And then you go back to your task and it's like, okay, you did this really hard thing. Is there like a contrast now where it's like
I think it's actually that, and I think it's also just that the ending of the difficult thing creates an increase. We know this, the removal of pain creates an increase in the catecholamines that it's like I'm interrupting myself, but from an evolutionary standpoint, if we go back to time, like what this circuitry really evolved for, it's like you just survived the effort. You just survived something, which is a tremendous relief, it's a lift. But when I say it's a lift, as a biologist, I have to acknowledge it's a neurochemical lift. Dopamine, epinephrine, norepinephrine, no doubt involved. Now, if you go too hard, too long, you exercise too hard, too long, well, then you get the post-exercise dip in energy and you might feel amotivated. But what we're really talking about here is generating a wave front in that dopamine pool that then you can devote to other things.
So it's interesting talking about the thing that you don't like. So you talk about cold exposure or like going really hard in the exercise. How does exercise generally affect the dopamine system? And does it depend on how much you enjoy doing it? The nice run on the beach.
Great question. There is unfortunately not as much data about this, about the influence of exercise on dopamine. There's some, but because it requires ideally brain imaging and exercise involves movement, it's been harder to do those sorts of experiments because people are in the magnet, often with a bite bar, and like your head has to stay stable. But in the case of cold water exposure and looking at the catecholamines, it was by blood draw. And I want to be fair, the levels of dopamine and other chemical increases by blood draw in the body don't always correlate directly. In fact, they never correlate directly with brain level changes in these chemicals, but they're loosely correlated. As one goes up, the other goes up. As one goes down, the other goes down. But unfortunately, we don't have great, real-time imaging of dopamine release or dopamine levels, with like a skull cap that you could, run without a bunch of equipment next to you. So there aren't as many studies about this, but there are some using blood draws because people can run on a treadmill, take blood and look, and certainly people can be scanned in the scanner as well. We know that intense exercise deploys the catecholamines. We know that. We know cold water does it as well. And a number of other things will as well. People playing a monetary reward game is the typical way this has been done in the lab while people are in a scanner. There's also some interesting data I just want to mention in 2 sentences where the way that the dopamine system is kind of checking off milestones. I talked before about pursuit, milestone. The human brain has a capacity to create long milestones like a 4-year degree or a marriage or, raising a kid, and also moment-to-moment milestones. There was an interesting experiment also published, I believe, in Neuron. I have to go back and check, but certainly Cell Press Journal by my recollection, that had people watching a sports game. And it was a basketball game. And every time the subject's favorite team got the ball and there was an opportunity for another basket, another score to take place, the dopamine circuitry sort of reset itself, if you will, toward anticipation of that particular drive down court. Now that's a perfect experiment in many ways because basketball has it's a very constrained environment, right? You know which team is going for which basket. You know when there's a turnover. When the turnover got reversed. It's not like most of life where you're in pursuit of things that it's very dynamic. A lot of interwoven goals throughout the day, et cetera. But the point being that as we move through our pursuits, the dopamine system is constantly updating. Okay, here's, if you will, a drive down court, right? Toward, and it's paying attention, or it has knowledge of even the sort of the shorter milestones. Like, as we move through this podcast, I'm not tracking where we are. I don't track time very well. I'm tracking whether or not I can answer your questions coherently enough, right? That's how my dopamine system right now is tacked to this, as opposed to people who are, gambling on a game in Vegas, and who final score is really what matters. But talk about dopamine and reward prediction error. That's what Vegas is all about, right? It's basically, the town should be called Dopamine Reward Prediction Error Town, USA, because that's what's going on there. So that was a little bit of a divergence into that one particular study. When it comes to exercise, there are a number of ways in which dopamine can be released in response to effort. Remember, the catecholamines, norepinephrine, epinephrine, and dopamine, close cousins, biochemically related, all of which are involved in heightened state of arousal, focus, movement, effort. Okay, it's just the kind of perfect cocktail that nature created. If we engage in we know that if you engage in vigorous exercise that requires effort, and you complete it in a way that feels satisfying to you, no doubt you're going to get a dopamine increase from that. Now, is it the long, elevated increase in dopamine, epinephrine, and norepinephrine that one sees with deliberate cold exposure? That's going to be pretty nuanced. It's going to depend on the nature of the exercise. I don't know. I suspect no. Now, I will say that I feel very different after a good long morning run or 30 minutes jogging versus a hard weight workout. It's just it's a subjectively distinct feeling in the hours afterwards. What's interesting about deliberate cold exposure, cold plunge or what have you, is that people generally report feeling very good, almost like a mild euphoria for many hours afterwards, elevated focus many hours afterwards. And that maps beautifully onto I can see those images in the paper now of the big dopamine increase and the norepinephrine increase. And I think it's 3 graphs set above one another vertically in that paper, where, this is long arcs of dopamine release way above baseline, distinctly different from what one sees with cocaine or amphetamine, which has also been measured in humans, the big amplitude, big drop below baseline. In fact, I'm not aware of, but that in fact, I'm not aware that what I'm about to say is always true, but in that paper about deliberate cold exposure, I did not see, probably because they didn't look out that far, a drop in those catecholamines below baseline. It may be that it just elevates and then tapers down to baseline again. Remember, the slope of the line, the faster you get up to a peak, the more of a drop below baseline. This is why people who smoke crack cocaine faster into the system than if they bring cocaine into their system by snorting it or orally. Okay, we know this. The route of administration has a lot to do with the amplitude of the dopamine peak and how far below baseline it drops afterwards. This is one of the reasons why certain forms of drugs of abuse are far more reinforcing than others. It's not just that they create a bigger dopamine increase, it's how quickly they get there and then how quickly and long that trough lasts. So with exercise, I get a clear state shift from exercise. I'm sure you do as well. And it's wonderful, but it's distinctly different from the kind of state shift that one gets from deliberate cold exposure. Again, less data. But one thing that's kind of fun that I don't think I've talked much about, if at all, on podcasts is the entrainment and anticipation of exercise. This is kind of neat. If you exercise at more or less the same time each day for 3 days, it doesn't even have to be consecutively. What you'll notice is going forward, at least for a short period of time, 15 to 30 minutes before that exercise, you'll notice kind of an increase in arousal where your body is entrained to that movement. The neurochemicals that were released, the state of arousal, there's some learning there between the memory systems, the hypothalamus, and the autonomic nervous system, and the body starts to anticipate being ready. If you then don't exercise, you can also apply that elevated readiness to mental work. People oftentimes will say they wake up right before their alarm clock goes off. Wild, right? You wake up, you look at your clock, it's like 1 more minute. What's going on? Well, assuming the clock didn't make some sort of noise, like a click or something like that, it's the entrainment to that waking up time. Even in sleep, your body is clocking time. Your brain is clocking time. And then you wake up and then the alarm goes off. The same thing is true if you exercise at the same time. And this is what's really interesting. If you exercise at more or less the same time, you can use that elevated arousal at that time to exercise or do other things. But then there's the post-exercise increase in whatever mental state you happen to exit that exercise from. Again, I say it that way. I'm not trying to be wishy-washy here because I find that a 8-minute HIIT workout is distinctly different from a long jog, is distinctly different from a hard leg day in the gym when it comes to how you feel afterwards. Each one has to be neurochemically distinct and hormonally distinct. And in the laboratory, unfortunately, most of the studies have been done like treadmilling or swimming. There aren't a lot of studies looking at the neurochemical changes that are the consequence of different types of exercise, especially things like HIIT and resistance training. I'm sure there are a few, I'm not aware of them, but they're far fewer than just cardio because it's harder to get people to come in and do a hard hack squats or something like that.
I think the biggest changes that's been done really with high intensity exercise and versus lower intensity or moderate would be looking at lactate and how that affects norepinephrine and other things. But it's the entrainment thing is interesting because I'm wondering if let's say you have someone who is not motivated to exercise, and the best thing you can do is get them a coach, right? That's going to help.
Right.
But if you can get them to do the 3 or 4 days in a row at the same time, then on the 5th or 6th day at that same time, are they going to now, because they have that, like you were saying, that motivation,
Yep.
that anticipation, which is tied to the dopamine system, then maybe you're going to tap into that, okay, we're going to get some of that motivation. So it would be interesting to come up with a protocol, how long is it, how many days of training the same time of day can we get someone who is completely unmotivated to exercise? They haven't experienced it, right?
I would say 3 to 7 days. If we, based on our understanding, of how the autonomic nervous system can learn, and how the dopamine system plays into that, 3 to 7 days, maybe not even consecutively. I always say that the most important thing with exercise, if I were going to write a chapter on exercise, is number 1, don't get hurt. But that doesn't mean don't do it, but don't get hurt, because the best way to get and stay in great shape in your life is to not get hurt, right? So you don't want the new exerciser to injure themselves, but 3 to 7 days. They should then on the 8th day or on the 4th day, left to their own devices, feel the energy in their body 15 to 30 minutes before doing that exercise, and hopefully they would just do that. I mean, I think that people rely often too heavily on psychological motivators, and we overlook this entrainment phenomenon, the ability for our body to entrain to certain times. For instance, it's a terrible thing, but I like to get up, hydrate, caffeinate, slowly do some mental work, and then my ideal training time, if I ever retire, I don't know that I ever will, but would be to train mid-morning, like 10:30. Amazing. I love it. My workouts are always best, et cetera. But my life isn't organized that way. So I like to try and exercise within an hour of waking up. But I have to drink caffeine first. I don't do my 90-minute delay thing. I drink my caffeine first if I'm going to exercise right away. And I should say that for people that feel amotivated, what do we do generally? We consume things like caffeine, which, as we know, disrupts the adenosine system. So adenosine being a molecule of sleepiness or fatigue, also upregulates dopamine receptors, incidentally. It's actually shown in human dopamine receptors, pretty interesting there. Regular caffeine consumption very likely increases the sensitivity and or number of dopamine receptors available. So whatever dopamine is released can have, quote unquote, more of an effect in terms of motivation and reward. People will take nowadays, and I'm not passing judgment here, but there's a lot of use of things like Adderall, modafinil, Vyvanse, stimulants. What do all those stimulants do? They release the catecholamines, mainly dopamine and epinephrine. They are amphetamines. Okay, people go, oh my goodness, speed. Yep, that's what they are. Again, not passing judgment. They can have certain positive effects for certain clinical issues in some cases. Again, not promoting or discouraging, just stating the reality. But what do people do? They take stimulants. What did I do right before this podcast? I'll come clean. I don't hide these things. I've been experimenting lately with 2 milligrams of nicotine, in the form of gum. I don't smoke, vape, dip, or snuff. Those are all bad, carcinogenic, et cetera. I know people say vaping's not as bad as smoking. Vaping's bad, okay? It's as bad as smoking? Probably not, but it's not good for you. Don't vape. I just got some enemies, but that's my read of the data. More coming. But nicotine taps into the acetylcholine system, increases focus. It also will tap into the epinephrine and dopamine system. It's highly reinforcing, so I limit myself to 2 milligrams, maybe 4 times a week total. And I'm thinking about stopping altogether because I'm just running this as an experiment on myself. And it really, really works for me. What does it do? It makes me more alert, more motivated. That also scares me. It's not, and many people I know that there are these pouches that come in canisters. I've never tried them. I don't want to. Those are generally 4 to 8 milligrams of nicotine per pouch. I hear over and over again that people take one, they love it, take one pouch. They then will do 2 a day, 3 a day, and pretty quickly they're consuming a canister or so, if not every day, every couple of days. So it's a very quick route to, let's just call it habit. Is it addictive? Maybe. Is it habit forming? Clearly. And this is becoming all the rage now. I don't recommend it. Nicotine is a vasoconstrictor, which isn't good, raises blood pressure, et cetera. There's some evidence that nicotine can be a cognitive enhancer, and maybe later in life, it might be something that I'll return to for that reason. But it does have certain health hazards. Clips always get cut of me saying the cognitive enhancing part. But the point here is that when people feel amotivated, they tend to look for something that they can ingest. Remember, no effort, get the molecules going. And there's nothing wrong with that. A cup of coffee or espresso or yerba mate, I'll do all 3 sometimes. And you're more alert, you're more arousal. You need to do something with that energy and then try and lean into work. The problem is with pharmacology, it's hard to get the dose just right so that you have the ideal level of focus, ideal level of alertness, but not so much that you have agitation and your mind is kind of darting all over the place. So my typical thing is I will use coffee or yerba mate or both prior to a hard weight workout. But when it comes to cardio, I try and do my cardio without any caffeine or even, and certainly no excessive caffeine, maybe a half a cup of coffee, maybe a yerba mate or 2, and then just get out and go run in my case, or do the HIIT workout and let the workout itself be its own source of neurochemicals. But that's just me. I know some people are doing the energy drinks combined with nicotine, combined with, all sorts of stuff. And it's wild because then what they find is in the absence of those things, they're amotivated. Well, why? It was minimal to zero effort, followed by high amplitude dopamine release, and probably less directly from the exercise that you're doing.
Right. You talked about the stacking of things that are releasing dopamine, either because you enjoy them or they're something that can release dopamine, a substance, is what will cause you to have the really high amplitude peak, and then you can go below baseline. How does caffeine from coffee affect? So you mentioned the dopamine receptors. Is there like long term? Because then you start to you never feel as good as if you take a break from caffeine, then you have that first cup of coffee, right?
I know. I can't say I relate because I can't remember the last time I took a break from caffeine. I've done it when I had flus or I was cold, had colds or flus, because I just don't want to drink caffeine under those conditions. Usually like chamomile tea, and I'm just huddling in bed or something. I love caffeine. I don't drink that much of it, but probably total out about 400 or 500 milligrams a day. I weigh 215, 220 pounds, so that's not that much, and I'm pretty caffeine acclimated. And I tend to drink caffeine in the early part of the day and not so much in the evening. Certainly not after 3 p.m., so I can sleep well. But the stacking is something that, I don't want to give the impression that if, you have an energy drink like a pre-workout and you got the music blasting and you're hydrated and you slept great and you have a great workout, crush a workout every once in a while. But don't be surprised if the next time you're walking into the gym, you don't feel quite as motivated. And I don't think one should rely on that every single time. That you need to, if you need a stimulant every time you're going to exercise, you are creating a pattern of behavior and likely some underlying neurochemical habits that are not going to serve you well in the long run. You're going to feel less motivation to do the thing that itself can generate feelings of motivation. And that's what we've been talking about. A cold shower would be a great one because of that long, I'm just fascinated by this. I've never seen anything else, no drug, prescription or otherwise, no supplement, no workout that I'm aware of, but I haven't explored every single one, that creates that long arc of dopamine, epinephrine, and norepinephrine release that 1 minute of being uncomfortably cold can create. Now, in that study, it was a longer exposure. They used warmer temperatures and it was much longer. But I think based on my understanding of things you presented and as I understand it, the shorter, colder exposure no doubt creates similar subjective experience.
Yeah. Well, I was going to ask you about that because there's a lot more papers looking at norepinephrine release with respect to cold exposure, and that can be even 20 seconds, at 39 degrees or whatever Fahrenheit. It's very cold.
That quickening of the breath, adrenaline is an incredible molecule.
But I'm wondering with the dopamine, what you think, and this can be some of your opinion, is the minimum duration and what the temperature should be to get, increase in the dopamine peak above what you're at, like you're talking about.
Yeah. So unfortunately, there hasn't been a lot of exploration of this, and there needs to be. And at one point, my colleague at Stanford, Craig Heller, who's done a lot on cold exposure and in particular palmar cooling for lowering core body temperature before exercise as a way to increase and prolong effort. A lot of Stanford athletes do this. Other athletes, pro athletes do this as well. Interesting topic. And I were considering doing some work on this, but we haven't gotten around to it. I guess we've both been busy with other things. But here's how I approach deliberate cold exposure. And people might scoff and say, well, that's completely subjective. But what I like about it, or what I'm about to say, is that it's highly individual. It doesn't say 40 degrees for 3 minutes, because 40 degrees for 3 minutes at 8 a.m. is going to feel very different than 40 degrees at 3 minutes at 3 a.m. No one's doing cold plunge at 3 a.m. unless they're in SEAL team training or something. But if you're tired, you're stressed, people have different levels of excitement about the cold or fear of the cold, and so on. Here's how I approach it. I think of everything in life as it relates to the stress system as coming at you as like a wall, an event, right? It's not, you're not thinking temperature and duration. You're not thinking, oh, how intense is this difficult conversation on a scale of 1 to 10 and how long is it lasting? That's not how the stress system works. We tend to be confronted with stressors that we either know are coming or are not coming. So the way I approach cold is I look at the cold plunge and I think, how resistant am I psychologically to getting in it? And usually it's very. I'm not excited to get in. I'm excited about the feeling I know will exist when I get out. So I think of getting in as the first wall. It's like climbing over a wall. Okay, this is the first wall. I get over that first wall and then I get in. I like to lower myself to my neck. I like to put my hands in. I try and move my arms away from my body because I notice when the cold water gets to my armpits, that's when it really starts to be uncomfortable. And I pay attention to my breathing a bit, or maybe I'll distract myself. I find it doesn't really matter. And what I'm waiting for is the first impulse to get out. So that's the second wall. And then I force myself to get over that second wall. Again, this is assuming that the water isn't so cold that it's going to be damaging. And then what I start doing is I start counting walls. And most importantly, I start paying attention to how far apart in time those walls are. Now, eventually you just go numb and you're not going to feel any wall. You'll go hypothermic. So you don't want to do that. But what I generally try and do is 5 to 10 walls. And it's very interesting to notice how the waves of desire, these what I'm calling walls, to I want to get out now. Now I'm going to just go over this next wall and this next one. What that seems to do, and I realize I'm not answering your question directly, but the reason I'm describing this is that so much has been put to the time and the temperature, but ultimately we are all highly individual in terms of how we react to stressors in a given moment. And what I find is that there's tremendous learning in noticing stress coming toward us confronting that stress, getting past that stress, and then moving through it. And then when I get out, I always feel much better. It's like, okay, there's a relief there. You get that arc of dopamine release that's quite long lasting. There's no question. I mean, you can like feel it in your body. I'm not trying to be too, anecdotal about this, but everyone feels different after cold. Maybe you're just relieved you got out, and that's it. But you feel different. And then what I'm trying to do is attach the fact that there was a feeling of accomplishment in having gone over a certain number of walls and paying attention. So again, this is not answering your question. I acknowledge this, but the ability to notice how stress hits you and how you move through stress, and then how your adrenaline system is like it's trying to create agitation so you get the hell out of the stressor. That's what it's doing. And your ability to stay calm and to ride through that in a safe way, that is a skill that I think is invaluable, far more than sitting there and just watching the clock tick down, getting out, and then enjoying the feeling of being out. Now, to directly answer your question, what are the different parameters that lead to different patterns of dopamine release? We don't know. Would 30 seconds at a very, very cold but still safe temperature do it? My guess is it would. My guess is that the catecholamines are released in a bolus in parallel from the locus ceruleus, norepinephrine, from the adrenals, adrenaline, from the various sources in the brain that can release dopamine, that they are just released in parallel. And we know they have different time courses. Well, that's even seen in that European Journal of Physiology paper. You see they have different time courses, different amplitudes. They're not, released as a little kit of Blue Angel planes flying right next to one another on those graphs. They have very different dynamics over time. But they are released in parallel. And then, would it be that 5 minutes at a 50% colder would release X more dopamine? Very likely. The problem is right now in 2024, we don't have great ways of measuring these things in real time. We just don't. We're just now getting to the point where you can measure things like insulin and blood glucose in real time in really careful ways while people are moving about. So the short answer is we don't know, but I do think that there's great value in paying attention to how one encounters stress, moves through stress. And then when you get out of the cold plunge, I don't tend to spend too much effort thinking about how I feel in that time. I just know that it's a complete state shift. I also know, based on my reading of my sleep, on my 8 sleeper Whoop, that doing cold plunge in the morning dramatically increases the amount of rapid eye movement sleep I get at night. And I don't know the exact reason for that. Not incidentally, certain forms of pharmacology, not drugs of abuse, but that I don't use regularly, but that I've used in the past, that increase dopamine and norepinephrine, like bupropion, will increase my rapid eye movement sleep dramatically. I currently don't take it. I took it years ago for a short bout of depression. I don't take it any longer, but I decided to take 50 milligrams of bupropion as a focus aid at one point, doing an experiment there. It didn't work well for me, but I noticed that my rapid eye movement at night just spiked like crazy. The duration increased by, I think it was about 15%. Then I stopped taking it and went back to its, previous value. So there's something about adrenaline release perhaps even just early in the day, that seems to impact sleep at night.
For people that are that don't have a cold plunge, and that are experiencing maybe a perhaps drop in their baseline dopamine, what are some other behaviors that can help to replenish the dopamine pool? I mean, we're talking about sleep. That would be one.
Yeah.
And also, like, how you were talking about just waiting too. Like, how long do you have to wait to experience that?
Yeah, well, cold shower is always great, and it's not just zero cost. It'll save you on your heating bill. Cold shower sucks because it's almost like the fact that part of you can be out of the cold makes it worse. You know, like part of you can be slightly warmer, whereas with the cold plunge, you're all in up to the neck, hopefully. Sometimes people get their hands out, and I don't judge. I think that's fine. People have different levels of vasoconstriction and pain from the cold. So you want to be fair, it does not a problem to keep your hands out, as I understand it. Cold shower is great. I think the high intensity interval training that I know you're a big fan of, that's a remarkable tool. Not only is it brief, but it deploys all these systems, these neurochemical systems that create alertness. Also, because it's brief and it does that, you're unlikely to fatigue yourself to the point where cognitive work is harder. This is something that isn't often discussed, but a good hard leg workout mid-morning for me is great. But then, then I eat a meal, and then by 2 or 3 in the afternoon, I haven't measured my brain oxygenation levels at those times, but I am not focused. It is really hard to focus. Whereas it's interesting, if I exercise earlier in the day, I notice a significant increase in energy all day long. I don't know why that is, or if anyone else has experienced that. But certain resistance training regimens can be really depleting, especially if you're doing sets to failure. And I try and limit my resistance training. I do it 3 times a week, ideally. And I try and do 10 minutes or 15 minutes of warm up, usually a smaller movement or something like that. Some warm-up sets, and then 45 to 55 minutes of work. And that's it. And the reason is, if I leave the gym then, I have energy to spare, mental and physical energy. Whereas if I take it to the point where everything's left on the mat, I'm just like depleted. I actually am depleted for several hours, if not days afterwards. Maybe my recovery quotient isn't as good. Maybe I'm not hydrating enough, but I try and do all the things. So, and still that's the case. So what I recommend people do, this is just what's worked for me, if they're a person that has other demands in life, they're not an athlete or solely devoted to their physical fitness, is I try and make 80 to 85% of my workouts about 80 to 85% intensity, meaning I'm not doing forced repetitions. I'm not pushing past an hour of total work, maybe even more like 45 to 55 minutes of total work. I try and do an additional 10% of workouts at higher intensity, 90% intensity. And this is all subjective, but this would mean more sets to failure. This would mean a couple of, advanced things like, forced reps or drop sets at the last set of an exercise. And then maybe just 5% of workouts, resistance or cardiovascular workouts, are all out, everything I can give. And so that really ends up being like, I don't know, just a few per year. For me, this last year, the hardest workout I did maybe ever was that 72-pound rock carry that Cam Haines had me do. Because there were moments during that thing, I told myself I wasn't going to put the rock down. And then when you say it on camera, you better not put the rock down. And Cam's there. And I just decided, that's it. This is the one. This is, for me, is like an 11 out of 10 effort. I don't know what more I had in me. Goggins would probably say I was only at 40% of what I could give, but it felt to me like everything I could possibly give. I don't do that sort of training very often. And I find it takes us back to a couple of important things. One is, the best way to get and stay in great shape is to not get hurt. You do those kinds of workouts too often, you're the person, the guy or gal with the injury that you're always talking about, right? That we hear from, my back, my this, my that. And they're not training, or they're in surgery, or they have to deal with pain stuff, which fortunately I don't. The other reason is that if you leave some gas in the tank, when we say gas in the tank, I don't think we're just talking about glycogen and caloric energy. I think we're talking about the riding of that neurochemical wavefront, and no doubt endocrine, hormonal wavefront also, and using that for other things. I mean, I use the cold plunge because I like the way it makes me feel, and I can apply it to work. I can apply it to energy. I can apply it to mood. outside of the cold plunge. I don't live to get in the cold plunge. I use the cold plunge to live. That wasn't meant to be a saying, but same thing with working out. I use the gym. I enjoy working out. I love running, but I use it as a stimulus for the brain that then I can go apply and be more present for other things. And I think if people looked at physical exercise that way, I think A, it would be less daunting. B, they'd really start to understand and appreciate how our physiology in one endeavor tethers to another endeavor, and you start to learn a lot about yourself. I mean, this is becoming a bit more, subjective as I describe it, but, for me, learning how one's body works and how the brain and body interact and how exercise influences cognitive function and mood, and I find it so important because that's how you navigate the challenges and also the great stuff of life. Whereas getting really tacked to just performance in the workout and then constraining it like that's it doesn't do much for me. Put differently, I have a little note on my laptop which says, completing a short bout of hard work always makes me feel better. And I have to remind myself that. Yeah, it's kind of cheesy. It's corny. I get it. But I wrote it, so I put it there. And I know that in the morning, there's this time when I can drift into doing things that are very passive consumption. But if I do one thing, read one chapter of a book, put together a post that is hard to deliver in one take, or go and read a paper, or do something that's challenging, it's like this lift in my brain and body that I can't describe. It's like I did the cold plunge. I have a long arc of elevated sense of accomplishment and well-being and motivation. And we haven't done the brain imaging experiment, but no doubt it's the translation of the activation of these very generic circuits for all forms of motivation to other things that I pivot into. So again, it's subjective. I'm not talking about a peer-reviewed study in that case, but I find it to be very useful just to learn how to do something challenging. And along those lines, forgive me for going long, that I'm just so excited about, there's this literature that's emerged recently on the anterior mid-cingulate cortex, which is a brain area most neuroscientists aren't aware of. But my colleague at Stanford, Joe Parvizi, who's a neurosurgeon, was poking around in this brain area, stimulating it in a patient, and then subsequently other patients, and found that if he stimulated in the anterior mid-cingulate cortex, these patients would describe a subjective feeling of like a storm coming or a challenge, and they felt like they were going to lean into it. Super interesting. Move the electrode back a little bit further, they don't report anything like that. Stimulate again in anterior mid-cingulate cortex, it's like there's a challenge coming, but I can take it. I mean, this is amazing, right? This is a state shift and a cognitive shift into forward center of mass. There are other studies showing that this brain area is maintained in size, in volume, in people that maintain cognitive function later into life. It increases in size and even activity in people who are successful dieters. It atrophies in people that fail to reach certain goals. There's now not a huge, but a decent sized body of work supporting the fact that the anterior mid-cingulate cortex, which by the way is a hub that gets input from lots of systems, including the dopamine system, memory, lots and lots of different brain areas, inputs and outputs to anterior mid-cingulate cortex. But it's a brain area that is engaged and that seems to increase in activity and maybe even size when we engage in effort that we don't want to engage in. So if you love working out, probably less activation of this brain structure. If you force yourself to do something, more activation of this brain structure. It seems to be related to tenacity, willpower, and possibly the desire to live. It might even be part of the circuitry to continue pushing on in life. Kind of a high-level concept, but these, what they call superagers, have, if you look at the brain areas that maintain size into later adulthood as compared to age-matched controls, the anterior mid-cingulate cortex is one of the two that represents the most significant difference. So I find this brain area to be really cool, and if ever there was motivation for taking on some hard things or a hard thing that you don't want to do, maybe it's resisting doing something, maybe it's doing something, I think it's the data on the anterior mid-cingulate cortex.
This, along the same lines, it kind of reminds me of some of, and I'd be curious to know what your thoughts are on the quality of data if you've looked at it. Doing something like transcranial direct stimulation or transcranial magnetic stimulation, maybe that brain region, or I think the prefrontal cortex. In terms of motivation, I mean, I think I came across a study. It was like people they stimulated a certain brain region and they were motivated to work out. Like
Yeah.
they were like motivated to
Sure.
exercise.
Yeah. I haven't seen that paper, but I said sure because it makes perfect sense. You know, transcranial magnetic stimulation, non-invasive approach, which originally was used to quiet brain areas, now can be used to stimulate brain areas. Ultrasound now can do this as well. My colleague Nolan Williams at Stanford is using this in combination with studies of psychedelics to increase plasticity in certain brain regions. I mean, it's a wonderful non-invasive way to activate or deactivate certain brain regions. Makes perfect sense to me that if one were to stimulate certain brain regions, people would feel more alert, more ready to go. In fact, there's a beautiful description of vagal nerve stimulation in I think it's a New Yorker article about my colleague Carl Diceroth, one of the greatest neuroscientists of all time. He's a bioengineer, a psychiatrist. And in that article, they describe an interaction he had with a patient. She has a stimulator on her vagus nerve. A lot of people think the vagus nerve stimulation always leads to states of calm. That is not true. Vagal nerve stimulation is one way to increase arousal and alertness. So we need to revise our understanding, or the sort of popular understanding of vagus. There's a conversation that's recorded in that article where this patient is sadly suicidally depressed. She's saying, you know, I don't want to live. I don't anticipate much of a future. I can't get excited about things. They ramp up the stimulation on her vagus nerve, which feeds into a number of the sort of core arousal circuits within the brain, hypothalamus, locus coeruleus, and elsewhere, either indirectly or directly. And in real time, she starts saying, yeah, you know, I could imagine myself going out and applying for a job or, you know, pursuing some, you know, it's like you're watching this depressive tone peel away, and not just peel away to a place of neutrality, but peel away to a place of forward center of mass. If ever there was evidence that like what goes on in our brains is influencing these broad motivational and psychological states, it's that. And I realize as people hear that, a lot of people say, well, of course, it's the brain, right? To stimulate one brain region, you get rage. Stimulate another brain region, people lean into effort. Stimulate another brain region, people start crying and are sad and they don't know why. It all makes sense, but what's so exciting about transcranial magnetic stimulation is that it's non-invasive. So we're not talking about a surgery. I think the issue is how precisely the stimulation can be delivered and then how persistently it needs to be delivered. So do people have to return to the clinic over and over again? And I really think in the next 5-10 years, thanks to the efforts of Neuralink and other laboratories, I mean, to be fair, you know, brain augmentation through electrodes is something that's been going on in academic laboratories for a long time. Neuralink is, you know, making great progress there as well. But I think the development of non-invasive tools, maybe it'll be, you know, you go in and they, you know, shave a small patch of hair, God forbid, a little bit, it'll grow back. And then they put a little, let's say dime-sized stimulator on the surface of the skull and close that up. And then by Bluetooth, every once in a while, someone is just stimulating magnetic stimulation of some brain area and they're feeling better. I imagine that will happen within 5 years or so. I don't think that it's going to require a wire down deep into the brain in every case. There will be cases where that's required, neurosurgery, but I think we're very quickly headed towards a time where non-invasive tools for directed brain stimulation in everybody who needs it is going to be the reality. And the beauty of neuroscience over the last 10 years is that the circuitries are being identified. I mean, what you need to know which brain areas to target, right? The anterior mid-cingulate cortex has been on the anatomy charts for a long time, but wasn't clear what it did. And so all this poking around with electrodes in neurosurgery patients is with purpose. And goodness, I mean, I can't think of a more important thing. And also, if you think about it, you're talking about the release of neurochemicals from specific circuits to get specific results. When people take a drug, which is one of the best tools we have now, people take a drug like, let's say Wellbutrin to increase dopamine and norepinephrine. It's doing that all over the brain. It's doing that, you know, in wherever, you know, those neuromodulators are able to be released. It's not selective for one particular circuit. It's also causing changes in the body. It has some positive effects, you know, hopefully, but potentially some negative effects. It depends. And dosages are hard to adjust in a very precise way. It's also hard to know in real time what's going on because you adjust a dosage and it takes 2 or 3 days or more for the changes to occur. With transcranial magnetic stimulation, you can know instantly. And so I'm very excited about this. Also, that the polarity of the stimulation can be switched from activation to inhibition. You always love that double dissociation in any experiment. Activate this brain area, get effect X. Deactivate the area, get the exact opposite effect, right? Somebody feels worse when you deactivate it. They feel better when you activate it as compared to baseline. Great. You now have pretty clear understanding what this brain area is involved in, probably involved in other things, but at least that. Awesome. And that's not far off. And it's happening in labs now.
It's super exciting and fascinating. I want to kind of shift gears for a minute and talk about, I didn't get a good sleep, I don't know, for a couple nights in a row. And I, have deadlines and things to work on. I was feeling very amotivated, as you like to say. And so I was, of course, deep in some of your stuff and came across this non-sleep deep rest. And I had never heard of it. I mean, I'm sure it's, become popular since you've talked about it, but I would love for you to talk about the non-sleep deep rest, NSDR. And, so sleep is important for replenishing dopamine. And I didn't get that replenishment of dopamine. And so some tools that people can do, again, we're talking about behavioral tools that we've just mentioned a few, but this non-sleep deep rest is interesting to me and how it can help replenish the baseline pools.
Yeah, so I first thought about and learned about something called yoga nidra. Yoga nidra means yoga sleep. This is a 1,000-year-old or more protocol where you lie down and you try to stay awake while remaining completely still. It involves some long exhale breathing, which we know slows the heart rate through respiratory sinus arrhythmia, which is a good thing. It slows the heart rate. And it had long been used as a way to offset sleep loss, as well as to just create states of replenished mental and physical vigor, even if you slept well. And there are a bunch of theories and some actually interesting writings about yoga nidra potentially allowing people to tap into intentions and things like that. Okay, great. I learned about this process, by the way. I went and somewhere around 2015, 2016, I decided to shift a significant portion of my lab from animal studies to human studies, and I was very interested in stress mitigation and trauma. So I went and visited a trauma treatment center in Florida where they were doing yoga nidra with people every morning for an hour. They would wake up, they would do this yoga nidra for an hour. I decided to participate once or twice, and I found it to be incredibly restorative because I wasn't sleeping well on that trip, and I would come out of it thinking I just felt like I slept 8 hours. I only slept 4 or 5 broken hours. I do this 1 hour of yoga nidra, and whoa, I feel amazing. This is wild. This is a big effect. What is this? Go back to my laboratory. We're studying stress mitigation techniques. And for whatever reason, I decided, okay, we could talk about yoga nidra, but it's a little bit like talking about meditation. And then you have these name, which is, a little complicated for the scientific literature because it's not clear exactly what it is. And I want to be very clear. I'm not trying to take anything away from yoga nidra or those practices. I have tremendous respect for them. But I came up with this thing called non-sleep deep rest, or NSDR for short, which A, gives people some sense of what they're doing, and B, strips away the intentions and any kind of mysticism whatsoever. And it really just involves lying down for anywhere from 10 to 30 minutes or an hour, I suppose. And people are doing long exhale breathing to slow their heart rate and calm down, doing a sort of body scan of paying attention to different parts of their body, trying to stay awake. But if they fall asleep, it's okay. We observe that it creates very dramatic decreases in sympathetic autonomic arousal, aka alertness, and places the brain and body into kind of a shallow state of sleep, not surprising, but a state that is unusual and, at least to my knowledge, not observed in other meditative states, that at least, to my knowledge. But to be fair, we didn't do neuroimaging of this, so we didn't have a lot of insight into it. I started digging around in the literature, and it turns out there's a study out of a medical hospital in Denmark that had people doing yoga nidra for an hour. So a very similar protocol, but an hour. And using what's called PET, positron emission tomography, measuring the amount of dopamine in the reserve pool in a certain key area of the brain called the striatum, which is involved in the generation of movement. It's also part of the reward and motivation pathway, although, there are a bunch of different pathways for dopamine. So I want to be clear about that. We talked about that earlier. So what they observed was really interesting. They observed, at least by positron emission tomography, that people who did this 1-hour Yoga Nidra protocol experienced a 60% above baseline increase in dopamine in these key brain areas, just from this hour of lying there completely still, trying to stay awake, listening to this script, relaxation. I think like this is wild. And then there's some other studies showing that post-Yoga Nidra performance on memory tasks or other cognitive tasks is improved. I got very excited about this and started whittling down the non-sleep deep rest protocol to what we hope is the minimal effective dose, which is about 10 minutes of non-sleep deep rest. We've done some exploration of that in my lab. Currently, there is a collaboration brewing between myself and Dr. Matthew Walker, the author of Why We Sleep, the great sleep researcher, the great Matt Walker, to explore what is happening at a neural level using brain imaging during non-sleep deep rest. Matt has my understanding is some insight or hypotheses. I don't know, what exactly is based on, so I want to be very clear. This is all very, very preliminary, that certain pockets of the brain might be able to undergo sleep-like states in things like NSDR, Yoga Nidra. That is not whole brain sleeping, but it might be pockets of brain areas going to sleep-like states. But the whole purpose of doing these experiments going forward, this collaboration, is to figure out exactly what's happening at a neural level during non-sleep deep rest and how closely it mimics sleep. Can you recover sleep that you lost? We don't know. Here's what we do know subjectively. And again, this is anecdata, if you will. These are people who have challenges falling asleep, often benefit from doing non-sleep deep rest, a 10-minute or 20-minute protocol at any time of day or night, because it's teaching you to self-direct your own relaxation. It's different than meditation because meditation involves focusing. Meditation is really a focusing perceptual exercise. Think about your third eye center, focus on your breath, redirect your focus every time it drifts. Meditation is a focus exercise, and work from Wendy Suzuki's lab at NYU has shown that it can improve performance in different cognitive tasks, but the traditional forms of meditation sometimes can disrupt people's ability to sleep well. Why? Well, you're increasing focus capacity. To fall asleep, you need to kind of defocus and let go of your thoughts. It's kind of interesting. At the beginning of all Yoga Nidra scripts, at least the ones I've heard, you hear you're going to move from thinking and doing to being and feeling, very new agey language. But let's explore that. Thinking and doing is about anticipation. It's about memory. To feeling and being, you're going into as much as possible, a purely sensory state, right? You're focusing on just how things feel. You're not thinking into the future, past. You're just thinking future or past. You're just feeling sensation in your body. Very interesting. And so different than meditation, different than hypnosis. Hypnosis is a sort of meditation designed to solve a specific problem. Quit smoking, relax, less pain. Okay, meditation, more of a focus exercise. Non-sleep deep rest is used to restore mental and physical vigor and to teach you to relax yourself. So it can be done in the middle of the night if you're having trouble sleeping. It can be done in the morning. This is when I typically like to do it. I did it this morning. I woke up at 5. That's a little early for me. Actually had a phone call for about an hour. And then I realized, oh goodness, I got to get up soon. I'm going to take 30 minutes and do a 30-minute non-sleep deep rest, or in this case, it was Yoga Nidra. I come out of that and I recall being in a pseudo sleep state. And I personally just feel as if I've slept 8 hours. And many people report this similar sensation. And again, it's subjective, but I think if ever there was a protocol that is useful for people to explore, given that it's safe, it's zero cost, and that sleep is so important and mental and physical vigor are so important, and the data on dopamine, it's a 10 to 20 minute Yoga Nidra or NSDR script. We've put a few of those out there on YouTube, and there are a lot of them out there. I really like, if I want a female voice, I'll listen to the ones by Kamini Desai, Desai, or Kelly Boys, Boys. She's on the Waking Up app. She has terrific NSDR scripts and Yoga Nidra scripts. And then there's some with my voice. I can't bear to hear the sound of my own voice, believe it or not. So we have a 10-minute and 20-minute one at our Clips channel. And there are a bunch of Spotify scripts, and you can find them out there. But to me, it's one of the more interesting aspects of protocols, meaning, we have exercise protocols, we have nutrition protocols, we've got deliberate heat exposure, deliberate cold exposure protocols. What about protocols for restoring mental and physical vigor that aren't meditation, that aren't hypnosis, that aren't pharmacology? And what does that look like? It's taking the brain out of that anticipatory mode. So if we speculate, go, okay, move from thinking and doing to being and feeling. Again, very new agey. But what are we doing? We're deliberately shifting our thinking away from the very types of thought and action that deplete the dopamine reserve pool, right? And should we be surprised that there's this significant increase in dopamine in the striatum post yoga nidra or NSDR? Probably not, because you're not tapping into that neural circuitry for a period of time. It also underscores the extent to which in our waking life, we are constantly in goal-directed behavior, even when we don't realize it. And so I find NSDR to be among the most potent and important tools or protocols that I've used in my own life. I've continued to do it about once a day, any time of day or night, sometimes based on need to get more sleep, sometimes just as a practice. And even 10 minutes of NSDR for me, I emerge from that feeling completely different and always better.
I did your 10-minute, one of your 10-minute NSDRs the other day.
How did it impact you?
It made me feel better. And I did it, like I said, I hadn't gotten sleep in the last 2 nights, and good sleep. It was like my sleep was disrupted. And so I stopped and I did your protocol, and listening to your voice was very soothing. And it also helped me, like I was able to shift right back into my work. Mm-hmm. And I don't know if it's because I was understanding, I was trying to read, how it's affecting dopamine, replenishing dopamine. And so I sort of believed myself into it, or if it just actually worked, right? I mean, so.
I hope so. It's also not a nap. Well, I'm glad you had a good experience with it. If people don't, of course, there's no obligation to do it again. It's different than a nap because it does not create sleep inertia. Matt Walker's talked about the fact that not everyone needs to nap, but a nap can improve cognitive performance. If you're going to nap, don't nap too late in the day, or certainly not if it's going to disrupt your nighttime sleep. A 20-minute nap seems to be the limit beyond which it can increase sleep inertia. You can wake up feeling groggy, have trouble waking up, and then people then will use caffeine, and then it disrupts their sleep. I like a 20-minute to 30-minute nap. I'm guilty of sometimes taking a 30-minute nap, but Yoga Nidra is being awake while deeply relaxed. And that's a very unusual state. I also want to just speculate a little bit further. There's some interesting ideas out there about how body still, mind active states can be very useful for creativity. We had a couple of guests on the podcast, including Carl Deiseroth. He has a practice, believe it or not, where he sits completely still, deliberately completely still, and forces himself to think in complete sentences for about an hour at night as a way to sort of practice thinking. Very interesting, body still, mind active. Then Rick Rubin, when he was on the podcast, not a scientist, but I'm fortunate to be friends with Rick. He does something similar. What is a part of life where the brain is very active, the body is completely still, and is known to be associated with ideas, learning, and creativity? Rapid eye movement, sleep. So there's something about the body being still and the mind remaining active that may lend itself to certain types of cognitive effort or cognitive endeavors. I don't know. This hasn't really been explored using neuroimaging, but I'm excited about this as a potential tool. And non-sleep deep rest and Yoga Nidra, again, the writing about it tends to be from these more ancient traditions, but starts off talking about replenishment of sleep, learning how to relax, et cetera. But remember, they were doing this at a trauma treatment clinic. And I asked them why. Is it to just calm everybody down, make sure they get enough sleep? And they said, no, we're doing so much work here trying to get people to remap their relationship to traumas. And they were really ahead of their time in understanding that the actual rewiring of neural circuits occurs during sleep. So they wanted to maximize the amount of deep rest that people were getting to maximize the rewiring, but also that in these states of deep rest, you also replenish the ability to lean into what really is the hard work of trauma therapy. It's not easy. And does the brain rewire itself more readily if we're doing NSDR, Yoga Nidra? I don't know. I suspect yes, based on the similarity to sleep, but that's one of the things that Matt and I would like to explore. Can it replace sleep that one's lost? Can it enhance the speed of learning? Can it reinforce learning in the same day? Because there's this thing called the first night effect, where the first night of sleep after a bout of learning is really critical for consolidating that learning. But let's face it, sometimes we don't get that night of sleep. So can you wake up the next morning and do a 30-minute NSDR and consolidate learning? Sometimes that learning is new information. Sometimes that learning is the dumping of information you don't want, right? This is why people who are rapid eye movement sleep deprived often carry forward a lot of emotionality that frankly they would like to unload. Then you get a great night's sleep and you're like, that thing that was bothering me, that's like nothing now, right? So rapid eye movement sleep is incredibly important. And yoga nidra, aka NSDR, or I should say NSDR is a build out from yoga nidra, in fairness. I think is a super powerful technique, and 10 minutes is pretty minor, investment.
Awesome. So we've been talking a lot about things that are positive behaviors to engage in to, improve our motivation, our focus, attention, dopamine system, replenishing the baseline. There's also behaviors to avoid, as we kind of were touch on a little bit. And, probably one of the biggest elephants in the room here would be the technology, our smart devices, our smartphones. You mentioned the brain loves visual information, and also the fact that we're addicted to getting looking at our likes, and when we get a lot of likes, we get a dopamine peak, and it's it's rewarding, right? And so
hugely rewarding, and sets the expectation for the next time,
right?
And the algorithms are very clever, right? Every once in a while, and a new account comes up. I know someone who recently started posting, and post, get some feedback, and then boom, something takes off, gets 1.5 million views. That will change their relationship to social media, maybe forever. You're just chasing that thing. And it's very clever. It's very clever. Not always diabolical, but very clever. Yeah.
So, what is that? There's a couple of questions. One is, what is that doing for our ability to live in everyday life that isn't like that, right? First of all, the visual information isn't there. It's not as, moving rapidly and all that things. And also, you don't get that huge peak from 1.5 million views. Everyday life isn't usually like that. And then the second is, how can someone have a more healthy habit? Like you and I, we have to use social media for our work. And a lot of people are like that, and so there's what's the healthy balance? How can you find it? Have you found it?
Have I found it? Most of the time, not all the time. I think two things. One is an observation. One is perhaps a suggestion to everyone. The observation is that disengaging from social media takes time, but it happens very readily every single time. So for instance, you get off work, you're still on your phone, you're with family, still on your phone. They're like, hey, want to engage? You put it away, expect some agitation. Expect like something's been taken away from you. It's this kind of low level malaise. Other things aren't as interesting. Hopefully one's life is interesting and hopefully isn't just drawing us out of like urgent demand. But it requires a little bit of time. If you've ever gone camping or you don't have access to your phone, in fact, this coming weekend, I'm going to take 3 days away from my phone. And I'm sure getting back to the phone will feel a little bit oppressive. It'll feel like a little bit oppressive. But once the phone is away, expect, 20 minutes to an hour during which you don't feel quite right, maybe even some underlying anxiety, because it's that unconscious anticipation. So that's the observation. The suggestion I have for people to have a healthy relationship with social media is one actually that I learned from a professional poker player, which is play for time. Don't, if you're winning, don't stay there, right? You're losing, don't, I guess I don't want to suggest people gamble, but this is all just translating to social media. Play for time. Designate how much time you're going to spend on there in a given bout. So for me, getting a post up once every day or so, maybe 4 times a week is kind of the goal. And I try and mix up the form of post. And I have rules for myself. Most specifically, I try and make sure that 90% of posts are so the audience can learn something useful, hopefully also interesting and actionable, et cetera. 10% are kind of from my delight. I can't help it. Or where I'm curious about, I'm kind of pinging the audience for their thoughts because I genuinely want to know. Like I was walking up the Upper East Side with my girlfriend a few weeks ago and saw this sign outside a store and it said, we have Ozempic and Mounjaro. And I took a picture of it and thought, that's kind of weird. It's normally you see like we have lattes or something. And I just kept walking. And then when I got back to California, I posted that on social media. I thought, kind of curious, what do people think of Ozempic and Mounjaro? I know it's controversial. I'll just ask people. And it was tons of engagement. I didn't even expect it, but I'm learning a lot from all those comments. So I have rules, but the main rule is I don't let myself or I try to not let myself pick up the phone and just at any old time and go into social media. I really try. I don't always succeed, but I really try. And if I'm going to be on there, I'm like, okay, I'm on here now for an hour, or I give myself an hour. That's the best thing I can do. I also know that if I answer a few comments, I'm kind of a runaway train when it comes to people pinging me with questions about science. It's very hard for me not to reply. So I have to limit myself to, 5 to 15 responses. And I'm like, and then I actually feel some anxiety as I go to do my life activities. I have to tell myself they'll be okay. It's just kind of like you ask a professor, at least this professor, a question about something. If I know the answer, like I'm going to try and tell you. So there's always that agitation, but for me, so expect that agitation when you set it away and play for time. Don't base it on any particular mode of engagement or whether or not it feels good or doesn't feel good. Play for time. So decide I'm going to be on here for 30 minutes. And it's interesting because when I don't do that, what I start to notice is I'm scrolling, but I don't even know what I'm doing. Like, what am I doing here? Like, what the hell am I doing here? Like, I don't even know that I care about this thing or that thing. It's nice to see people in their events. I love the baby pics and the animal pics and our friends in the podcast space. It's always great to see and to learn. I learn a lot from your posts. I genuinely do. I learn a lot from Lane Norton's posts. I genuinely do. And I really enjoy the podcasters, the public facing health folks. But I know also, and I remind myself that for me, the real raw materials for the podcast, unless it's a post from you, to be honest, I'm not just saying that. The real raw materials tend to come from PubMed. They come from books. They come from papers that I'm reading, thoughts that I'm going to have, like conversations I'm going to have. And so those are the raw materials for my work. And that social media is more of a mode of consumption and occasionally broadcast. X and Twitter, totally different picture. Because I now go on X and Twitter and I know they're going to try and get me through a, let's just call it a psychosocial dynamic. Someone like you're on there to see how people are going to engage. It is a little bit more combative. It also can be really supportive because of the immediate retweet function. You see something you like, you can get out to a lot of people. You can link out to things. But it's more of a like the center of the town square where everybody's interacting. And so I have very clear cognitive pictures of like Instagram feels pretty benevolent to me. People have to generally show their face, right? X feels like, okay, do I really want to engage in this very intense dynamic? So I go on X far less, and I've had much more polarized responses to things that I've put up there. I've had things clipped out of context. I've had attacks, and I just don't enjoy being angry. I don't enjoy feeling that friction. It just sucks for me, and I don't like seeing other people suffer. So on X, I see just a lot more of that, and I've got nothing against it, and I think they've done great things with the platform, but I have to just be really protective of myself to not go there terribly much.
Is there like studies that have shown there's a maximum amount of time that like adults, maybe children versus adults, should spend like with their smart devices to, prevent these huge amplitude and peaks in dopamine where they're just getting, really rewarding things, or even just like you're saying, negative things that can be in a way it's very, you're getting that like engagement and that, it's
the clap back, if you get a good clap back on somebody. I mean, there's a neuroscientist up at University of Washington, Sam Golden, who's shown that, animals will work for the opportunity to fight. They'll work for it. We never understood this until recently. I mean, you could say we always understood that, but no, humans probably do. Engaging in those kind of high intensity ways can be rewarding for some folks, even for people who don't like that, unless they're really conflict averse. It has a certain level of arousal itself can become rewarding, right? Just the engagement, when I say arousal, like the level of cognitive engagement, especially if the rest of life feels kind of passive and uninteresting. There have not been clear studies that I'm aware of, but at the same time, if I think of something like virtual reality, like my colleague at Stanford, Jeremy Bailenson, has done, he's one of the early pioneers of virtual reality. And as virtual reality came to be, they established, and I'll get the numbers wrong here, so forgive me, Jeremy, I have to look this up, but limits of, kids should only be in the VR goggles for X number of minutes per day, and it was minutes. Otherwise, there's rewiring of the visual system and vestibular system, the balance system, in ways that might not be healthy. They had real clear limits and guidelines. With social media, it was sort of like as much as you want. And then, of course, there's the intrusion of social media and tablet use and phone use into sleep, where then you're depleting the where you're undermining the replenishment of the dopamine reserve, right? So then there's all that contextual stuff. I think an hour a day on Instagram, if you think about it, that's a pretty significant investment. And with X, I can't even make a recommendation. I do go on there and post. I have a kind of a bittersweet relation to it right now. Lex Friedman, our buddy, has a far more kind of symbiotic relationship with X. It just sort of like works for him, whereas I feel that more on an Instagram platform. And it's different cultures, and maybe I need to adjust my follows and so on. But I think an hour a day to me just seems like, okay, that's plenty and is enough.
What role do you think that going to things like Instagram, Twitter, and TikTok, this context switching where you're working, but then you're checking Twitter, and then what role is that playing in our ability to focus and attention, ADHD-like symptoms? I mean, there was I read last night, 1 in 9 children has ADHD. Now, I don't know
wow.
what that actually means, but yeah, wow, exactly. Mm-hmm.
Yeah, I think because I grew up and spend still a fair amount of time in the Bay Area, although I'm in Los Angeles far more now. An interesting question is always to ask the heads of these companies or the CEOs how long they let their kids be on social media, and you'll often find that it's a very, very small number. And that tells you something right there. Okay, so I think the task switching, the context switching, no doubt is impairing adults' ability to engage and stay engaged in one thing. Reading a book, unless it's extremely engaging, is going to be less attention harnessing than social media. Why? Because social media is movies. Why? You're scrolling. I mean, the brain has never seen this kind of thing before. Even if you have 300 channels on your television, and you're just scrolling at short distance with the feedback of people you recognize, and which isn't true for most people with watching television, or and feedback and likes and comments and clapbacks and attacks and reward. I mean, it's incredible. I think I'm a content consumer, but I'm a content creator, as you are, of course. And I like to think in terms of, are we consuming content or are we creating content? And just being very judicious about consumption of content. I mean, I think it's great fun, and I encourage people to put stuff out on the social media. In fact, recently a clip was cut. There was like a math gaffe that I did, and I came out and apologized for the error. I occasionally make errors in podcasts, and we put them in the captions. But anyway, put something out there. But the caption to that post was, I would hate for anyone to resist posting their creative thoughts, their creative outlet, for fear of attack or making mistakes. I think we need to, I sound kind of like, it's a party line now, but to foster a community of people, encouraging people to create stuff and put it online. But that's different than just passive consumption all the time. I think there's so much good to be had with social media, but I think an hour a day on Instagram, maybe 30 minutes a day on X, and you're good. And even there, 90 minutes out of your waking day. And then what part of your day? This is important. When I look at my day, I know that when I wake up in the morning, I'm a little groggy, but then I've got 3 or 4 hours that if I'm going to get really quality work done, it's in that 3 or 4 hours or the 3 or 4 hours right after lunch. And that's it. I'm not the kind of person that's doing quality work now between the hours of 8 p.m. and midnight. It's just not happening anymore. It happened years ago, but it's not happening anymore. So where is that 60 to 90 minutes falling is also key. Maybe it should be for an hour or so before bedtime, provided it's not too stimulating. Maybe it should be over your lunch break. You just handle it then. But when it's first thing in the morning, then several times throughout the morning, and then later in the afternoon, and then in the evening, I think what I'm describing is not unusual. And not unusual, not just for kids. Jonathan Haidt's work that's being discussed so much now about social media consumption and the challenges and concerns with that, but also in adults. I mean, since when? I'm 48 years old, and it's kind of remarkable. I mean, I see people from my high school class, and I'm one of them, so I can only laugh at myself here. But it's like we're grown adults, posting what we did and showing it off to the world. There's a kind of teenage element to it. it's kind of like silly if I really step back from it. I go, wait, like, are the adults behaving like kids and the kids are behaving like adults? Like, what's going on here? And again, there's use of sharing science and other creative crafts but
well, aren't they chasing the dopamine? The dopamine like? I mean, they're getting likes.
Yeah, it just shows that adults
engagement
adults are just as prone to it. But it's sort of, if we step back and looked at ourselves like an experiment, we'd say, wow, like the people in the 35 to 60-year-old range of this species that we call human is kind of like doing the same stuff that the kids are doing. And maybe you just say, well, duh, but it's interesting. I mean, and you say, well, like how good or poor of one's life is that? And so I think about this stuff a lot. But I'm on there and I teach and I enjoy it and I learn and and I'll continue. But I think one has to be really discerning and set constraints.
Absolutely.
Yeah.
I mean, if it's tapping into your dopamine system and if it's kind of like that substance, right? It's technology. It's not methamphetamine. It's not cocaine, but it sure as heck is affecting your dopamine system. And so
it absolutely is. And it also has the potential for a lot of problems. This isn't a domain that, I have expertise in or that is covered on the podcast, but, there's this guy on who's done some podcasts with Lex Friedman, and he's been on a few others, James Sexton. He's a divorce lawyer in New York. And he talks about how the advent of social media has created this huge surge in I don't know if overall divorce rates, but then, he talks about the trajectory of a lot of the failures of a lot of marriages. And it's like, and actually people have talked about Instagram as like one of the main dating apps. It's not sold as it's not offered as a dating app, but this is where a lot of people meet. They see people they used to know, hey, how's it going? And then the conversation converts. I mean, this is, I'm neither saying, I'm not passing judgment. I'm just saying, there's a lot in the landscape of social media that lends itself to too much ease in certain types of human interaction, and that inhibits our ability to do things that are really functional for our relationships and for our professional lives and for family. I mean, or just presence, just like being there. Not to get sentimental here, but that graduate advisor I was talking about before unfortunately passed away young. She had the BRCA mutation, died at 50. Her name was Barbara Chapman, had two lovely daughters. Actually, the second one just finished university in neurosciences, so I was super happy for her. And I'll never forget at her, it wasn't her funeral, but it was a kind of like celebration of life thing after she ended, that her daughters, maybe it was one or both, talked about how one of the best things about their mom and their memories of their mom was unstructured time with her, where she would just like sit with them and hang out and they would just like do stuff. And she wasn't a heavy user of the phone. So that was 2014, she passed away. So phones were kind of really beginning to pick up in terms of their use, smartphones. But I that rung in my mind because I was thinking, wow, like of all the things for children to remember about their deceased mom, it was the unstructured time. It wasn't the Giants game, although they probably remember that. They were big Giants fans or other things. But it's the unstructured time that we spend with people where they are giving us their full presence and we're giving them our full presence. And then you look around at like dinner tables now in restaurants, you look around and like everyone's on their phones. Anyway, I'm saying what everyone already knows and I'm guilty of it too, but I think the world is due for an adjustment. So
kind of on the same lines of this technology thing, but shifting gears more to light, circadian rhythm. Oh, yeah. I mean, this is vision.
Perhaps my favorite topic.
Perhaps your favorite topic.
I am obsessed. Yeah.
I spend a lot of time at my computer, as do you and many people, and we're all, we spend a lot of time indoors, working on our laptops or computers, whatever. And I've heard you talk about something very interesting, which is this low solar angle, viewing. Mm-hmm. And I'd love to have you elaborate on that because I've always heard, and Sachin Panda was the first to really kind of get me interested in this topic, our mutual friend, wonderful chronobiologist, yes, talking about early morning bright light exposure and how important it is for resetting our circadian rhythm, which, as for people listening, is our 24-hour clock. And everything is on this cycle, as you know, more than I do, about our metabolism, getting sleepy, our wakefulness, as you mentioned, our arousal, all this stuff. But I would love to know about this low solar angle light and how that ties into our circadian rhythm.
Yeah. So some just real quick overview of some very simple biology. lining the back of your two eyes like a pie crust is your neural retina. These are the neurons that transmit information about the amount and quality of light in our environment to the brain. And then the brain does various things with it. There's a pathway directly from the eyes to the hypothalamus. There's a collection of neurons there called the suprachiasmatic nucleus that dictate our master circadian rhythms that essentially cause all the other cells of our body to be on a similar schedule or control the clocks within all the other cells of our body. There's a pathway from our neural retinas, of course, to areas of the thalamus, which is essentially a relay station up to the visual cortex for conscious perception of things like color, shape, and edges and things like that. And this system is the main system by which we know where we are in space, vision, in physical space, and time. Now, the time part is a little bit more mysterious to most people, but the way it works is the following. Obviously, the sun rises and the sun sets. And our bodies, our internal milieu, need to know where we are in time within the course of a day and longer within the course of a year as well. We can talk about circadian rhythms in a bit. But there's a special category of neuron called the retinal ganglion cell, which is the cell that actually passes electrical information into the brain. And that cell has a bunch of different types. Some of them respond to edges, to colors, et cetera. But there's a specific type called the intrinsically photosensitive melanopsin retinal ganglion cell, a real mouthful, that Sachin and Samar Hattar and Iggy Provencio and David Burson and others characterized in the early 2000s and for the subsequent years and still characterizing, that is a neuron that's not as concerned with the shapes of things or the colors of things, although we'll talk about color in a moment, but rather how bright it is in a given environment. And it is those cells and the activation of those cells that so-called sets our circadian clock so that we have elevated daytime mood, focus, and alertness, and that we fall asleep at night and stay asleep. Okay, so low solar angle sunlight turns out to be the optimal stimulus for these cells. What do I mean by low solar angle? I mean when the sun is low in the sky. So that's twice a day. It's in the morning and in the evening. Low solar angle sunlight, even on cloudy days, okay, even on overcast days, is distinctly different for this system than when the sun is overhead. Why? Okay, so we have in humans we are trichromats, unless we're red-green colorblind, which is like 1 in 80 males, I think. We are trichromats. We have what sometimes is called a blue cone, a green cone, and a red cone, but that really means that they absorb short wavelength, medium wavelength, or long wavelength light. And from that, we generate this incredible thing in our brain, which is trichromacy, the ability to see the difference between reds and greens and grays and purples. It's incredible. A mantis shrimp can see far more of those things, but we can see a lot of different color variation based on the absorption of those different wavelengths of light. The intrinsically photosensitive ganglion cells have their own pigment within them. They don't need input from these cones, but they get it and they use it. This is important. They get it and they use it. So these cells are brightness detectors, such that if you shine a really bright light on your eyes, let's say in the middle of the day, you walk outside in San Diego, Los Angeles, even overcast day, like before we came in here today, really bright, tons of photon energy coming in, far brighter than even under these bright artificial lights here, even though here it looks really bright. If we were to measure this, the environment we're in now is probably, 1,500 to 2,000 lux. Outdoors is probably 10,000 to 50,000 lux. It's just a wild difference. And again, that's even behind cloud cover. The middle of the day constitutes what's called the circadian dead zone, meaning bright light at that time is known to improve mood on the skin, provided you don't burn. Maybe we talk about sunburn and sunscreen. Maybe we don't, or avoid that third rail. By the way, I use sunscreen, the right one.
As do I.
As does Rhonda. Despite what you might read or hear about on the internet, we both said it. We both use sunscreen, and we just use the right ones and avoid the wrong ones. The light in the middle of the day will improve mood by activating these melanopsin cells. It will improve alertness. On the skin, there's evidence that it can improve the output of certain hormones like testosterone and estrogen, feelings of well-being, study out of Israel a few years ago in Cell Press. But that light in the middle of the day, if you see the sun, don't stare at the sun, but if you see it, it looks like white and blue light, right? All wavelengths essentially coming at you, full spectrum. In the morning, when the sun is low in the sky, you'll notice that there are blues and there are like yellows and oranges, maybe even reds if it's a beautiful desert sunrise. And in the evening, of course, the sunset has all that richness of the long wavelength light, orange, red, etc., and blue. And it turns out that the cells that set your circadian clock, these melanopsin intrinsically photosensitive ganglion cells, yes, they respond to bright light, very high intensities of light, such as at midday or from maybe a sunlight simulator of just blue light in a home environment if you purchase a so-called SAD lamp. But the optimal stimulus is that low solar angle sunlight in the morning especially and in the evening, because those cones, and in particular the short wavelength responsive cones, the blue, aka blue light, and the longer wavelength, the reds, the orange, they converge in terms of driving the activation of those cells, those melanopsin cells, and they activate those cells robustly early in the day, meaning when you see contrast between blue and orange or blue and red, which is characteristic of low solar angle sunlight, you are driving the activation of those intrinsically photosensitive ganglion cells the most, and you are sending the primordial, evolutionarily conserved, robust signal to your brain, the day is starting. You're going to activate a huge number of different endocrine, neural, and other systems, immune functions in the body. Now, what this translates to is, even if it's overcast, get out as soon as the sun is up. Sorry, I should restate that. Even if it's overcast, as close to waking as possible, get some sunlight in your eyes. Now, notice I said sunlight. You don't have to see the sun as a physical object. Get the light in your eyes. Early day sunlight is going to be most valuable for setting your circadian rhythm. Now, what's interesting is that all species that we are aware of, like dogs, for instance, they're not trichromats, they're dichromats, but they have a short wavelength cone and a long wavelength cone. Look at a dog in the morning or in the afternoon, and they will look in the direction of the sun. Birds have the pineal that can get light through the skull, so slightly different, but all species have all species have a dedicated system in the eye and brain to extract the specific qualities of light that are present at early in the day, low solar angle sunlight, and again in the evening, low solar angle sunlight, to convert that into neural and hormone signals that the brain can understand. Put very simply, get outside for 5 minutes or so in the morning, maybe 10 minutes if it's overcast. Don't wear sunglasses for this. Don't stare at the sun. Eyeglasses and contacts are fine. Don't try and do it through a window. That's not going to work. Too much is filtered out. And just look in the direction of the sun, the general direction, and you will improve daytime mood, focus, and alertness, and it sets a timer for your nighttime sleep. Now, people say, well, I wake up before the sun comes out. What can I do? I was just saying, well, listen, unless you have powers I'm not aware of, you got to wait. If you don't have access to sunlight for whatever reason, for about $100, I don't have any relationship to any of these companies, you can get a 10,000 lux light panel, and you can make your coffee in front of that. It's not quite as good as the yellow, blue, orange, blue contrast system that's going to come from low solar angle sunlight, but it's going to be better than nothing. Now, there's a diabolical twist in all of this, and then there's a solution also based on low solar angle sunlight. The diabolical twist is that early in the day and throughout the day, bright artificial lights are not sufficient for all the good stuff that you want from light. You either need a sunlight simulator or ideally you just get outside for a bit in the morning. After, say, 16 hours of being awake or so, however, it only takes a small amount of bright light to quash the amount of melatonin that's present and to disrupt your nighttime sleep. So you need a lot of light early and throughout the day, but don't get sunburned and don't damage your eyes. And you want a minimal amount of light at night. In fact, I've vastly improved my transition into sleep by, I'm not talking about red light panels, but just buying some red light bulbs. There are a couple of companies that make these. You can look for them inexpensively, and just going to amber or red lights before sleep for about half an hour. It's known to be to prevent some cortisol increase that can come from bright lights of the blue variety. Some people will just use blue blockers, and I have no objection to that. Now, what do you do if you're going to be under bright lights at night? Viewing evening light can partially offset the negative effects of bright light later at night. and this was shown in a really nice paper where they looked at the degree of melatonin suppression to bright light at night, depending on whether or not people had seen some bright light in that study designed to mimic sunlight in the evening for, I believe it was, somewhere between 10 and 30 minutes in the evening. Now, not everyone has time to watch a sunset in the evening, but just getting outside, popping the sunglasses off while you're walking to your car after work is going to partially offset some of the negative effects of artificial lights at night. And now we could get into a whole description about what's actually happening with low solar angle sunlight, and I'm happy to do that. But suffice to say that the contrast between these, oranges and blues, or yellows and blues, or reds and blues that are occurring when the sun is relatively low in the sky. You don't actually have to see it crossing the horizon, but if you do, great. Relatively low in the sky. It's that contrast at about 19 hertz, believe it or not, that's the optimal stimulation for these cells. And there is one company, I don't have an affiliation, called 20 Life, that has developed a bulb that mimics this. It's actually built by some absolutely spectacular circadian biologists up at the University of Washington. The bulb, unfortunately for me, is a little bit cumbersome because it involves an app, and hopefully they'll make an app-free version, but it flickers at 19 hertz between blue and orange. It's designed to mimic the sunrise and sunset. So people can, if you like geeking out on light technology, you can do that. But I think there's still some improvements that need to be made. And I'm saying this specifically so they'll make those improvements, because I do like the technology. It's the only one that I'm aware of that's grounded in the logic of how the biology actually is organized, with this contrast between long and short wavelength light. But all this is to say, get morning sunlight in your eyes, try and get it again in the evening. Great during the day, but don't burn. And at night, try and dim the lights as much as you can, meaning as is reasonable for whatever activities. And don't sweat it if you don't get bright light in your eyes or sunlight early in the day once. This is a slow integrating system. But after about 2 or 3 days, you'll notice that things like your sleep will start to drift later. Your morning energy will drift later. There's also a really interesting effect of cortisol, where bright light exposure early in the day increases the total amount of cortisol by about 50%. People hear cortisol and they go, oh, I don't want elevated cortisol. You want your cortisol elevated early in the day, and then you want to taper off end of day. Spikes or increases in late day cortisol are associated with depression and anxiety. Work from our psychiatry department at Stanford has shown that, and others have shown that. So you want that big amplitude and then cruising down out of that cortisol release early in the day. And bright light is one way to do it. That cortisol increase will provide some important activation of certain immune system components, of alertness, of focus. We don't want to treat cortisol as the enemy. It's just about timing and amount.
Right. You mentioned the 5 minutes being enough, like early morning bright light exposure, and it's like, is it an hour and a half? How long is this low anger in the morning? How long is the low anger angles?
Probably until, it depends on time of year, of course, and location. Where probably until about 10 a.m. or so. Just if I had to put a rough number out there. So if you're waking up at 9, just get outside. If you wake up at 6, get outside. If you can catch the sunrise, amazing. I mean, that's the ticket. But most of us are not doing that, or not because we were not waking up early enough necessarily. But we get up, and if you're in an apartment, can you get to a place where you can see the sunrise across the horizon? But look, if it's combined with a walk, some hydration, some caffeine, and maybe even social time or time with your dog, even better. There's no reason why you can't combine these things.
And so, also the cortisol one, is that like, how much light do you remember how much light was needed in the morning?
It was
quite a bit.
Yeah. And they used artificial light because it was a laboratory situation, but it was designed to mimic sunlight. I have to go look it up. I'm sorry, I don't recall
hours,
off the top of my head. I don't think it was hours. I think it was on the order of minutes. I'd be surprised if it was more than an hour. If you get in front of one of these 10,000 lux light panels, and I have one, I bought it on Amazon. It sits actually on our shelf. So in the morning in the kitchen, so I'm making coffee or something, it's right there, right in front of my supplements actually. So I'm there, I'm doling out my supplements, and there it is. It's about the size of a computer monitor. And after about 5-10 minutes in front of that thing, you kind of want to get away from it. It's really bright, and some people get a little bit too much activation if they're in front of it for too long. And then of course at night, you don't want to be anywhere near that thing. You want it off. I have one in my gym as well. So if I go into my gym, the lights in my house aren't particularly bright. I'll turn that thing on. And so I'm getting a lot of photons, but of course nothing beats sunlight. Nothing beats sunlight. And if you can get a morning walk in the direction of the sun in the morning as the sun is rising, then you've done something right in life.
Right. Or if you just want to go outside and drink your coffee out on your, porch or patio or in your yard, whatever. So along those same lines with, the technology and viewing things, it's the topic of the short distance viewing, and that's something that I think pretty much. I haven't heard a lot of people talk about this in taking breaks from, because we're always, again, everything's so different than it was, decades ago when people were not inside all the time looking at a computer or a screen, something that is very, very short distance away from our eyes. What is that doing to our vision, and how does something like long distance viewing, as you call it, help counter that? How much do you need to do?
Yeah, it's wild. The rates of myopia and nearsightedness are going way up. Okay, nearsightedness is not just a throwaway phrase. Basically, as light enters the eye, the lens focuses that light onto the neural retina. Nearsightedness is a change in the shape of the eyeball, and there's some other things too that have that image landing closer to the lens, too close. Nearsightedness, as opposed to farsightedness, where it lands behind the neural retina, the neural retina being the detector of that light. So there are a couple of different ways to manage that. One is to put a lens in front of the eye, an eyeglass or a contact, that then adjusts the position that it arrives to the neural retina. One thing I should say is that there are some big studies, many, many thousands of subjects. These are still somewhat preliminary, but they're exciting enough that most ophthalmologists who read the literature are into this, that show that kids mostly that spend 2 hours or more of time out of doors during the day, even if they're on tablets or computers or phones, have a lower incidence of myopia. Now that's not it's not causal, right? But it's an interesting correlation. So get outside. Maybe kids should be doing some of their work outside. Again, don't sunburn, but very interesting. The other thing is that early in development, and really up until let's say our mid-20s, if we do a lot of close viewing, the eyeball actually changes shape and lends itself to things like myopia. Some people think, well, how could that possibly be? Well, there are these classic studies mainly done in chickens, but then it carries over to humans as well, where they would put glasses on these animals, where they would essentially view something up close or further away, or natural viewing, and the shape of the eyeball lens, and therefore the position that light is focused into the eye, changes. So you can create myopia by looking at things too closely for too long. And it's probably the case that even in adulthood, if you're not myopic or nearsighted early in life, that too much close viewing causes some changes in the shape of the eyeball that does this. Okay? So the idea is pretty simple. If you're going to be looking at things up close a lot, which we all are nowadays, you would be wise to also take a few minutes each day and try and view a horizon. I mean, how often do we do that now? To get some horizon viewing and or panoramic vision. So when we look at something, so-called foveate to it, we're like directing our vision towards it. And if we really sharpen that to a point, we're doing what's called a vergence eye movement. If we were to track the movements of your eyes, you notice that they kind of focus inward a little bit and they really direct it at something. That's fine and good. In fact, it's great. It's part of our primate evolution to be able to do that, as opposed to animals with lateralized eyes that can't really do that. But it does create a state of heightened internal arousal. There's an associated, it's really activation of locus ceruleus, that brain area that we talked about before for release of norepinephrine, and other things. But it's really creating a ramp up in attention. So when you're on your phone scrolling, you're foveating to this small box, independent of what's in that small box and what you're viewing and how that's affecting you. And you just imagine the amount of time that you're doing that, or texting while walking to your car, while on the bus, while commuting, or in any kind of environment. Whereas for the many, many hundreds of thousands of years or more prior to that, you would just walk between things and your vision would go into what's called panoramic vision, where you're not really foveating or placing a vergence eye movement to anything in particular unless you're interested in it, you're pursuing it, analyzing it, etc. So it can be very relaxing and beneficial to just take a walk with a couple minutes of just letting your head and eyes go wherever they want to go, not directing them to any one location in particular, meaning not looking at your phone, right? You can look at whatever you want as long as you want, appreciate things around you, appreciate people around you, but going into panoramic vision, long distance viewing, very useful. And if you're stuck in an indoor environment and you're finding that you're feeling anxious, sometimes that's related to all sorts of things in the room, temperature, air, people, agitation, whatever. But if you want to calm down, I've talked a lot about physiological size, 2 inhales followed by a long exhale. Fastest way I'm aware of to shift your nervous system to a more parasympathetic mode, and calm down. But also you can dilate your gaze even without moving your head or eyes. You don't have to be rigid with your head or eyes and fix them in place, but you can just try and view the ceiling, the walls, the floor, and everything around you in sort of more of a global manner. And that releases this, intense, what I'm calling foveation or vergence eye movements. It's a little bit of a trick. It's kind of nice because it's completely covert, whereas physiological size, 2 deep inhales through the nose followed by a long exhale through the mouth, a little bit harder to hide if you're trying to, cloak whatever level of anxiety one might be feeling. So if I right now went, given that it's me, it might not be so strange, but it's a little weird to do in a meeting. But you can just kind of relax yourself through going from vergence to panoramic vision. But even better would be get outside, view your horizon, let your eyes let them relax so that you're not looking at one particular thing for too long. And you'll notice undoubtedly a pretty major state shift to a state of more calm.
If people are in, let's say, an office building or something and can't, is this a scenario where they can look out the window?
Yes.
Okay.
Yes, this would be a good case for looking out the window. And for students who were looking out the window in class, you can just say, I was trying to catch some anxiety relief, and then maybe your teacher will let you get away with it.
Speaking of anxiety, I'm trying to be mindful of your time. I know you have to go soon. I just want to try to dive into one last topic.
Sure. No, I'm enjoying this
alcohol.
so much. Alcohol.
Okay. It's a topic that you really, I think, have changed the public perspective, in terms of public health, with respect to the effects of alcohol, particularly on the brain. And, I don't think there's any controversy about heavy alcohol use and how it's negative for every organ that we have, right? It's just very bad. There's been a lot of, I would say, conflicting ideas and conflicting research and just disagreement with respect to what would be considered maybe perhaps moderate alcohol, which many, many people do, 1 glass of wine a night or something with dinner, or even less than that would be light alcohol consumption. So maybe, less than 2 or maybe 2 or 3, less than 3 drinks, 3 or less.
Per week. Yeah.
Per week,
yeah.
Yes.
Yeah.
First of all, I want to talk about anxiety that triggered me, but I want to ask you about someone that's doing, let's say, moderate drinking. So they're doing, the glass of wine a night. What's that doing to parts of their brain in terms of the structure and the function?
Yeah. So first of all, do as you wish, but know what you're doing. That's my stance. I am not anti-alcohol. I'm not an alcoholic. I don't particularly like alcohol, so I can drink or not drink. I don't tend to drink. I might have a sip of alcohol. Well, it's been a long time since I've had a sip of alcohol, but there are certain white tequilas I've enjoyed, and occasionally one of those, and or a vodka and soda or something. So just to be clear, I'm not anti-alcohol. My read of the data are, as you pointed out, that yes, alcohol is a poison, but many things are a poison, and the dose determines the poison. It seems that our threshold for what we call moderate or low amounts of drinking is shifting nowadays. I don't know if that had something to do with the alcohol episode that we did, but here's what I do know. The data say that 0 to 2 drinks per week, you're probably fine, provided you're not an alcoholic and you're of age, okay? And you're not pregnant or dealing with some other, something that would make it a case where you wouldn't want to drink at all. 0 to 2 drinks per week. Now, what happens past 2 drinks per week depends on a lot of other contextual factors, okay? First of all, how well or poorly you metabolize alcohol, how much alcohol dehydrogenase you tend to express. Why do I say that? Well, a lot of the so-called negative effects of alcohol are due to disruptions in sleep and gut microbiome. So those are indirect, right? Alcohol is changing, for the worse, the gut microbiome and sleep patterns. We know this. People that track their sleep, they have 1 drink and they're like, holy cow, my sleep is so much worse. Not just sleep score, but amount of REM sleep, amount of deep sleep, et cetera. Is that the direct or indirect cause of any kind of disruption in brain structure or in neuronal health. We don't know. But what these larger scale studies show is that if you look at the amount of gray matter thinning, which occurs with age regardless, gray matter being the neurons in the brain, white matter being the fiber tracts, the axons and myelin in the brain, this is how they're imaged, so they show up as gray or white. The amount of gray matter thinning starts to increase as you get out past 2 drinks per week. Now, is it significant enough that people should be concerned about cognitive decline as a consequence of 3 drinks per week induced gray matter thinning? Probably not. So then should we set the threshold at 3 drinks per week or 4 drinks per week? I don't know, and I'm not here to say that one way or the other. What I'm saying is my read of the data, and I know there are people that disagree with me, is that 0 is better than any. And that, I think, I'm told, has brought great relief to a number of people that didn't want to drink, but that actually were drinking red wine specifically to try and get some quote unquote health benefits. It also brought great relief to a number of people because they tell me that did not like drinking. They didn't like the way drinking made them feel, either while they were under the influence of it or maybe taste or just general malaise the next day or due to disruption in sleep. I don't really know the reasons. But for people who don't like drinking or who don't want to drink, I think there's ample evidence that 0 is great, that you don't need to drink. Okay. It might seem like a kind of silly statement, but I think a good number of people are kind of doing it because they thought there were health benefits. Now, to be fair, most people were drinking, and if they were talking about the health benefits, because they like the way alcohol makes them feel. And to me, it's clear that if you care very much about your brain, that more than 2 drinks per week on a consistent basis, probably not a good idea. Now, are there exceptions to that? Sure. Are there people who, everyone says, well, I had a grandparent and they lived to be 98 and they're super sharp and they drank, a shot of vodka every night. Great. Great. I just say, well, how much better would they have been had they not? But I also understand you need to live life. And for many people, alcohol is one route by which they enjoy life more because of its relaxing effects. And that's important to note that anxiety is bad. Anxiety that disrupts sleep is bad. So many people will drink to provide a segue from the work day to the evening, and they find it helps them calm down and sleep better. But we know it disrupts your sleep. Would it be better to not drink at all? Probably, but I want to be respectful of that scenario as well. If we look at 4 drinks per week, 5 drinks per week, let's say a drink a night, 7 drinks per week, I just don't see where the debate is. To me, you look at the gray matter thinning, you look at some of the other metrics on gut microbiome, you look at the disruption in sleep, and again, people should do as they wish, but know what they're doing. And it's just so clear that it's not good for people and that they're doing at least some degree of harm. Now, there's also the business of offsetting harm. I always say, listen, if you're the kind of person who wants to have a drink every night, be my guest if that serves you well. But you might be wise to also do some things that offset some of the, for instance, gut microbiome disruption. Perhaps pay a bit more attention to consuming 1 to 4 servings of low sugar fermented foods per day to really feed the gut microbiome. Maybe be extra thoughtful about a consistent sleep schedule. Maybe be extra thoughtful about a number of other things to offset whatever negative effects are sure to be introduced by that kind of regimen. So 0's best, 2's probably fine. 3, 4, 5, 6, 7 is where are you going to shorten your life by a significant amount? Well, provided you don't drive while you're drunk. Probably not. Are you going to be disrupting your health? Probably. Mainly indirect effects through disrupted sleep or gut microbiome, try and offset those effects. But then once you get past, a drink per night, which many people are consuming, then I think there's general agreement. Higher incidence of cancers, especially in women, higher incidence of cancers generally, and a number of other things related to immune system disruption. So, and on and on. And, just as a final statement, I don't have anything against alcohol. The alcohol is, I understand it's part of the fabric of most every culture, and that says something. But to my mind, alcohol, if you don't like it or you care about your health more than you care about alcohol, I say, don't drink. It's pure and simple.
What does alcohol do to our serotonin system, dopamine system? I mean, while we're drinking, while we're consuming it, you feel good. I don't know, exactly what's happening at that moment, but also long term, like after you're done with the alcohol. Like what happens to that serotonin system?
Lots of animal data, not a lot of human data. Here's what we do know. Most people experience the what they subjectively report as pleasant feelings of alcohol as disruption of inhibition, relaxation, et cetera. And that's mainly through the GABA system. And there are a couple other systems as well. There is a subset of people for whom, for whatever reason, it seems they get more activation of the dopamine system from alcohol. These people may be, and very likely are, more prone to becoming alcoholics. One of the strongest determinants of whether or not somebody becomes an alcoholic is the age at which they took their first drink. So very, very young, higher likelihood they'll become an alcoholic and so on. But there does seem to be some genetic predisposition or some other predisposition for folks that drink and seem to be very energized by alcohol. There's kind of a coordinate release of dopamine from the dopamine system that's not always observed in other people. But again, there aren't a ton of human studies on this, but there's some, what I think, logical speculation that can be had that those are likely going to be the people that are drinking and staying up drinking throughout the night. I knew these people in college. It was kind of interesting to see that some people would just like drink and drink and drink, and they're upright and they're clear. You're thinking, gosh, is their tolerance very high? Well, surely that's the case. But it also seemed as if alcohol was affecting them differently. And then, of course, there's the whole notion of blackout drunk where people are awake and alert and they don't realize what's happening, and that's super scary. So the dopamine system is involved in perhaps so the dopamine system is involved at a low level, we can say, almost certainly in everybody when it comes to alcohol. It has reinforcing properties, especially if people like the feeling, they like the circumstances. Again, it's that contextual learning about what happens when they drink. A number of people, proven, by the way, that if somebody gets really, really sick after drinking a certain type of cocktail, they're very likely to be averse to that cocktail forever after. There's this subset of individuals, maybe a little less than 10% or so, that perhaps it experiences heightened increases in dopamine release in response to alcohol that other people don't. So that's interesting and certainly needs more study. And then you asked about the serotonin system. Here, I have to apologize. I'm not aware of the direct relationship between alcohol consumption and the serotonin system, but I am aware that there's this phenomenon of anxiety where people, yes, achieve some relief from anxiety while they're under the effects of alcohol, but that the next day, the part of the hangover effect seems to be a elevation in anxiety, so-called hangxiety. Is that directly due to depletion of or some disruption in the serotonin system? I don't know. Seems likely. One of the phrases that we have to keep in mind, there was a professor of mine where I was a graduate student. He used to say, a drug is a substance that when injected into an animal or consumed by a human produces a scientific paper. What I think he was saying is that, when it comes to the neuromodulators, there's a lot of interaction, so that I have to imagine that if you took two groups of people and you gave one group alcohol or you titrated and you give some high alcohol, moderate alcohol, low alcohol, and then you looked at circulating serotonin, I wouldn't be at all surprised to see differences. The question is whether or not those differences can be tacked directly to any kind of subjective change. So there, I have to admit being naive, and so I'm sure someone will tell us in comments that what alcohol is doing to the serotonin system. Serotonin, I think, for a long time, was looked at only as kind of a calming neuromodulator or something like that. And I think we now appreciate that it's doing a lot of different things in a lot of different brain structures, not unlike dopamine, but perhaps even more so. Because you see evidence out there for serotonin and resilience, but also serotonin and pair bonding. I mean, it's involved in so many things. And so what we need to ask is, what circuits in the brain is serotonin modulating? And certainly it's modulating a lot of them, and in many ways in a much more widespread manner than is dopamine.
Well, I've read a lot of the literature with alcohol as well and come to the same conclusion as you, where, it's not like it's good for you. I couldn't convince myself that drinking alcohol is actually good for you, but I think I found that 2 drinks a week doesn't seem to have a lot of the negative effects of brain atrophy and cancer and other things. And
great. I'm glad we agree. Yeah. I'm glad we agree. I mean, not that if we disagreed it would be a problem, but I consensus is great. even if it's a small group in consensus. I think attitudes towards alcohol are changing, and as are attitudes towards cannabis. It has certain health benefits and medicinal benefits, and also can be problematic for certain people. And I think more understanding of genetic and other predispositions to alcoholism, to psychosis, to things like that are going to be really valuable as we go forward. We just really don't know what to look for yet. But again, it's been a while. Maybe I'll have a drink at some point.
There's a dopamine connection to being predisposed to being an alcoholic. So I don't remember if it was which one it was, if one of the dopamine receptor ones or another one. There's a handful of them. I would say 5 that are known that affect likelihood to be ADHD, to have substance abuse disorders, alcoholism. I mean, all this makes sense, right? Everything that we were talking about. To being able to like deal with stress and anxiety. And so I'm very interested in that interaction with the genetics, and also like, okay, well, if you have ADHD, so these things that we've been talking about in the podcast, in the episode, not limiting the phone to 1 hour a day, and doing the NSDR, the non-sleep deep rest, and the exercise, and the cold shower, cold plunge if you have it, and all these things can help even people with ADHD.
Yeah, they tap into the dopamine and norepinephrine system. And I also want to acknowledge that a lot of the prescription drugs for ADHD can really help people, children and adults. I did 2 episodes on dopamine and focus and ADHD. The first one was mainly focused on behavioral, nutritional, supplementation-based approaches. And I would say about 50% of the comments were, love this, thank you. The other 50% were, I hate this, what about all the drugs that are really valuable for it? So we did a second episode, as we were originally planning to do, on Adderall, Vyvanse, Ritalin, dioxine, which is actually methamphetamine, prescription methamphetamine. These things are prescribed to try and help people with ADHD and other attentional issues. And the response was exactly inverse. 50% of people saying, this is fantastic, thank you. Parents thanking us for doing that, because a lot of them were living in kind of quiet shame about the fact that they were giving these drugs to their kids, but observing that their kids were feeling better and doing better and performing better. And then the other 50% were saying, this is all terrible, we're putting kids on speed. And so again, I don't come to any of this with any kind of judgment. I think it's highly individual, but what it all comes back down to are these neuromodulators, right? And the various circuits involved. It's the catecholamines in both cases, whether or not it's a cold plunge or whether or not it's Adderall. It's not the same route to it. It's not the same level. It's not the same predictability. So I'm not trying to equate those two things, but they all funnel into the same mechanistic system. So we shouldn't be surprised at all that, yes, there are behaviors. There are things to avoid. There are prescription drugs. And yes, there are supplement-based compounds that tap into these pathways. Mecunopurines, for instance.
What do you think of that?
Well, it's L-Dopa. L-Dopa is a precursor to dopamine. And so if people it's true, supplements are not as regulated, as we both know. Sourcing becomes an issue. I've tried mecunopurines. I don't have ADHD, but I've tried it. It gives you a clear state shift. I mean, you're taking L-Dopa. It produced a pretty big crash for me afterwards. And I'm like, I never want to try that again. But I think people are very individual. I think getting the baseline things right, sleep, stress modulation, exercise, nutrition. Look, there's absolutely no way that can't serve a person, young or old, for the better. And so that should be the place to start. But in many situations where there's a clinical urgency to get a kid focusing so that they don't fall behind in school, I'm of the mind that, it makes perfect sense for parents to safely explore some of the pharmaceutical approaches. But if they don't work, they also need other places to turn. And while they're doing that exploration of what's going to really work best for this kid or this adult, one would hope they're doing all the things to bolster that system, that catecholamine system, with great sleep, NSTR, maybe cold plunges, exercise, nutrition, et cetera, so that the whole system doesn't crash while they're doing it. And that's really what I believe. I can't speak for you, but I really think that your work and my work is really what we're trying to do, is trying to get all of that information out to people, for people to look at, evaluate, and make decisions for the best situation in their hands. And does that mean that certain drugs are being overprescribed? No, they are in some cases. And in some cases, they're being underprescribed, and somebody's really tortured by their inability to focus, and they could do well with some low dose of some particular drug. And then we say, well, are we creating, a generation of addicts? They're going to depend on these things? Maybe, but maybe it's also encouraging the kind of neuroplasticity in the intentional systems that's going to allow them to be able to focus without these compounds.
Yeah, I think my concern is the who is diagnosing it. Like, I read a study when I was trying to decide, like, okay, like my son was born in it was in the summer, right? And so all parents are kind of faced with this. When do I start kindergarten?
Oh, right.
Right. So I was starting.
And I'm a September baby, so I'm always the youngest in my class.
Right. And so that was exactly what I was looking into. And I was looking into, reading what's out there in published data. And I read a couple of studies where children that were boys that were born in July and August were 3 times more likely to be diagnosed with ADHD than boys that were not born in July and August.
Wow.
Okay. So they were the youngest, they were going to be the youngest in their class. There's nothing about being born in July and August that makes a child susceptible to ADHD. Right. Let's be real, right?
So it has to be the early struggle with keeping up with
what's happening,
cognitively more mature.
Teachers are comparing younger kids. The school readiness for boys is not the same as a girl, for one. And then on top of that, you add youth, where they're younger. And so you have a child that can't sit still and focus, and then and it's distracting and fidgety and all of those things. And then all of a sudden you have this, I think your child has ADHD, and then you go down this sort of path. And so, my concern with that 1 in 9 number that I cited, and I was like, 1 in 9, that's nuts. Like, is that real? Or are we just do we have a system where we're putting kids in this environment that they're not meant to be in the way, at least in the way that we're doing it? And then now all of a sudden we're creating this situation where some kids, these girls can sit nicely and follow directions. It's really easy and they can sit for hours and hours and hours. But you know what? A lot of kids can't do that. Do they have ADHD? I don't know. Maybe they don't. Maybe they just need to get out and move around more. Maybe some kids do. Absolutely. It's definitely, there's a spectrum, right? It's not just, it's a spectrum. But yeah, I think my take on, you're talking about people's feedback and the 50% are
roughly, yeah.
Yeah. So I know exactly what you mean, but I do think part of it is the diagnosis, and do they really have ADHD, and what, maybe we all kind of have it somewhat because of our modern life now, right?
Or the capacity for it. I mean, what you're really talking about in that age difference in the late, the July, August kids is that, you look at a group of young kids, and some are moving spontaneously and looking around a lot, and some can sit still, and it's top-down suppression from the forebrain. The prefrontal cortex does many, many things, but one of its main roles, as was described to me by a really brilliant neurosurgeon, actually the head neurosurgeon at Neuralink, Matt McDougall, is the prefrontal cortex job is to send a signal to the other circuits of the brain to say, shh, to quiet that down. And that comes online, meaning it matures very slowly in the early years of life. It's when kids learn to defer gratification, right? Marshmallow test, it's when, there are other things too, of course. It's when kids learn contextual rules, when to say please and thank you, when to run around and have, be crazy, and, and when to try and sit still. And kids are developing that at different rates. It's developing at different rates in them. Now, we know one thing about ADHD, which is interesting, at least one thing, which is that it does not mean a total lack of capacity to focus, because oftentimes a kid with ADHD, you put them in front of something they really enjoy, like a puzzle or a video game or a particular doll game or whatever, and they are wrapped with attention. And that tells us right there that the circuits work, but that the threshold for their activation is somehow altered. And it's clearly engaged in one context, but less easily engaged in other contexts. Now, let's face it, we're all like that. If something's really exciting and interesting to you, it fully engages you. If it doesn't, it's not going to. And I do think that these circuits, even once they develop, they can be unpeeled a bit through lack of reading, lack of focus, lack of, time in conversation like this, directed conversation. I often feel that podcasting, whether or not it's a solo episode or an episode like this, one of the great pleasures of it is that, we're engaging face-to-face in a conversation. We haven't looked at our phones once. That's exceedingly rare if we were at a restaurant or cafe or out in the world. So I think we can all train up and we train down these circuits. And much of what we call schooling early in life is training these circuits. Some kids can benefit from pharmacologic assistance. Some likely don't. Some adults can benefit from pharmacologic assistance. In fact, I've talked to a number of psychiatrists that have said that oftentimes adults who, they don't abuse, but they heavily use stimulants like caffeine, and they require a lot of caffeine in order to focus, might be a low-grade ADHD. I'm not diagnosing anyone. I'm not a clinician, but I find that interesting. Are they seeking the same catecholamine stimulation that one would get from, let's say, low-dose modafinil or from Vyvanse or Adderall? And in which case, which one would you go with? Would you say maybe a little Nicorette or something like that? Again, I'm moving away from the nicotine thing. I think that experiment's over for me because of the concern about the vasoconstriction. So to be clear, I'm not going to stay with it. But, all the behaviors, all the supplements, all the nutrition, all the prescription drugs, they are not haphazard. They center back to these core mechanisms. Today, we've mainly been talking about the catecholamine system, dopamine in particular, but these other systems as well. And so it all makes perfect sense why these ADHD-like patterns emerge. And it also makes sense why certain treatments would work. And what I love is that the behavioral stuff is quite potent in its ability to tap into these systems. Is it the same as taking X number of milligrams of Adderall or Vyvanse? No, but it certainly gives people at least an additional line of entry to explore. And given that these things are low cost or zero cost, typically zero cost, there's just a little bit of time investment, and that they also do other healthy things for us. I think it's great. And I love how the health space is emerging around this. I think the conversation is going to get better, not worse, for all of this stuff, as long as we're not on our phones too damn much.
Speaking of healthy habits, so you talked about your workout routine. I'd love to sort of end on your healthy habits that you do maybe daily, weekly, your diet, supplements. You talked about your workout, sleep.
Yeah. So I try and get to bed by about 10, maybe 11 p.m. I don't always succeed. I wake up around 6 a.m. or so. If I don't sleep enough or I don't feel rested, I'll do a 10 to 20 minute, maybe 30 minute NSDR or yoga nidra. I get up. I like to hydrate. First thing I try and do is drink 16 to 32 ounces of water. I like just hydrate in the morning. Get outside and get some sunlight. If I can't get the sunlight, I get in front of that 10,000 lux light. I prefer to work out early in the day, in which case I'll drink caffeine if it's a resistance training workout. That for me, that's yerba mate or coffee or both sometimes. I'll just tell you my workout schedule is really easy to hit on. Same thing I've been doing roughly for 30 years, although sometimes I've been less focused on it and let it lapse a bit here and there. So first day of the week, for me, it falls on a Monday, but it could be any day. I train my legs. Calves, hamstrings, quads. I'm a big believer in glute ham raises, hack squats, leg curls, leg extensions, calf raises. Just keep the lower body strong, keep the posterior chain strong. There are a bunch of different ways to do this. One could do it with kettlebell swings or deadlifts, but those are the things that work well for me and that I can consistently add load or other ways of increasing intensity without getting hurt. Okay, knock on wood. The whole thing takes about an hour. Next day, is a rest day, typically after leg day, and I'll try and I don't always do, but some deliberate heat and deliberate cold exposure. In an ideal world, it's 20 minutes of sauna, 3 to 5 minutes of cold, 20 minutes of sauna, 3 to 5 minutes of cold, 20 minutes of sauna, 3 to 5 minutes of cold. And yes, I finish with a warm shower because I'm a human being, and I like that. And I will listen to podcasts or books or something while I do it, and helps my recovery. It's also just thermal training. It has all the benefits of sauna and cold, and I like to do it on that day. The next day, I'll do typically a run, a 25 or 30 minute run at a kind of faster pace. So where I'm, breathing hard for most of it, but it's not all out, maybe 85% of effort. And that's it. The next day I train my torso. I know a lot of people roll their eyes. They'll be like, what are you talking about? How do you, I do some overhead pressing, some dips, some pull-ups or chin-ups, and some rowing. And then I do some abdominal work, and I train my neck because it's an important part of the structure of the upper body to keep the head stable and not get text neck and things like that. I don't train it heavy, but I train my neck, and I do make sure I do things like rear delts. I really am trying to emphasize, outward, external rotation of the limbs, so we're not, kind of like hunched over like this and heavy in the traps, just upright posture, those kinds of things. And then the next day, the only workout is about 10 minutes long. It's that 10-second hard cycling on the assault bike, 20-second rest, 10, 20, 10, 20 for 8 rounds. That's it, VO2 max. Saturdays, another short resistance training workout, so 3 total for the week. And then it's, biceps, triceps, calves, little neck work, abdominal work. It's kind of just small body part stuff. And then on Sunday, which for me falls on a Sunday, I try and do some long ruck or hike, often socially, put on a backpack with some weight, or if I'm by myself, I'll do, a 60 to 90 minute jog or something of that sort. Maybe hike part of it and listen to music or just let my thoughts go. So what it boils down to is 6 days of training per week, 3 resistance training sessions, 1 longer slow run, 1 moderate one, and 1 short one. The total amount of time is actually quite low when you think about it. And then there's that rest day where I may or may not do the heat and cold. This schedule I could micro dissect, but what ends up happening with this schedule is because, for instance, I'll train my legs on Monday directly, but I'm doing the assault bike for HIIT on Friday. So my legs sort of get targeted twice per week, once directly, once indirectly. So I don't have to worry about too little frequency of stimulation for things like strength and hypertrophy, although I'm not trying to grow anymore, for maintaining muscle. Similarly, I'll train my torso on that one day during the middle of the week, but you're using your arms for that, and then you train your arms directly another day. And on the arm day, I'm doing some dip-like things, and so you're also hitting your torso muscle. So I never worry that it's not frequent enough. I find that getting into the gym more than 3 days per week or doing resistance training more than 3 days per week, I start to lose my motivation for it. But I like to be really focused and targeted when I'm there. And I love long runs, I love moderate runs, and I love the HIIT workout. So I get to do a little bit of everything. And I really want to emphasize that because I'm not a professional athlete or even an amateur athlete, the whole basis of this thing is to be able to do anything. Meaning I can go for a long hike or backpack during the summer with a heavy pack, no problem. I can sprint for the airplane. No problem. I can lift things without hurting myself. No problem, provided I'm smart about it. I'm not trying to be the strongest, the biggest, or the fastest, or the one with the most endurance. Just kind of all around life. And none of these workouts is longer than an hour. And in many cases, they're 12 minutes or 30 minutes. Okay. The daily routine is pretty much consistent. And I should say that schedule, if I travel, things might slide a bit. I might move day 1 next to day 2. I move things around, but I'm careful to never weight train more than 2 days in a row. I personally don't recover. I don't like doing that. Okay. Nutrition, I just try and emphasize non-processed or minimally processed foods. I'm not really hungry until about 11 a.m. And then I like some meat, some berries, some rice or oatmeal sometimes, and some vegetable. I'm not low carb. In the afternoon, I'll generally have a snack, maybe a protein drink, some nuts. I do eat, those Maui Nui jerky sticks or a thing of bone broth or something. It's not promotion, it's just a fact. And then for dinner, I tend to emphasize less protein. For me, that works. This runs counter to what everyone says, but I like more vegetables, pasta, rice, risottos. Occasionally I'll go out for a big steak or something like that. But generally the heavier on the starches, not heavy, but heavier on the starches relatively, and vegetables. And then a couple hours before sleep, ideally. But sometimes I'll finish dinner and collapse. It's just life. I do find that I sleep better if I allow a few hours before sleep. In terms of stress modulation and things like that, I do deploy the physiological sigh, which sounds very technical, but 2 inhales through the nose, followed by a long exhale to lungs empty. I try and do that anytime I feel that my stress is too high. My lab published a clinical trial in Cell Reports Medicine in collaboration with David Spiegel's laboratory at Stanford, showing that 5 minutes a day of breath work of cyclic sighing, so inhale, inhale, exhale, both inhales through the nose, inhale, inhale, exhale, done as a dedicated practice for 5 minutes a day, led to some interesting changes, positive changes in reductions in resting heart rate, reductions in blood pressure, improvements in sleep, mood, et cetera. Not all significant, but several which were statistically significant. But I don't tend to do breath work. I tend to just use the physiological sigh whenever I'm feeling kind of overly ramped up. I do drink caffeine. I drink in the morning, sometimes in the afternoon. Supplements. Okay, this could be a long discussion. Our friend Brian McKenzie used to tease me. If you ask me what supplements I take, he'll just shout from the background, all of them. I don't take all of them, but here's what I do take. In the morning, I do take Tongali and Fedogia. This is kind of for freeing up testosterone and for luteinizing hormone stimulation. For me, I've been on it for years. It works great. It shifted my testosterone and free testosterone in the right direction subtly, not super significantly, but subtly and meaningfully. For me, it works. Some people have not had good results with it. Some people have. By the way, I have no relationship to any supplement company. I do have a relationship to AG1 and Element. We can talk about AG1 if you want. But this is not a promotion of any kind. We used to be associated with Momentous. We parted ways on great terms. It just was part and parcel for some other brand relationships we had. So search for best sources if you're going to explore these things. I make it a point to take at least a gram of EPA, form of essential fatty acids, in the form of fish oil. Probably more like 2 grams per day is what I'm shooting for. You've talked a lot about this. I make that a point. For me, I feel better. Okay, my blood work looks good, and that's something I really strive to do. And then I take a bunch of things that I don't know the extent to which they've really shifted my physiology in the best direction, but I know it hasn't made me worse, and I feel better. Okay, what am I talking about? I take a multivitamin with my first meal of the day just to cover any basis that I might be missing out on. I take a ginger capsule. It seems to improve my digestion. I take a couple digestive enzymes when I eat. I take 100 milligrams of zinc with that meal. I do that consistently. I take, let's see, what else is in there? I take a low dose of boron, and there are a few other, and I make sure that I get enough vitamin D and K2, about 5,000 IU of vitamin D per day, and some K2, and a little bit of grapeseed extract. And that's it. That's it. Before sleep, I will use magnesium and apigenin 30 minutes before sleep. And I've been exploring some other things for sleep. In full disclosure, because I just think it's really important, I've experimented with various peptides recently. To be honest, they are so potent in certain directions that impact my sleep that I've started to kind of back away from most of them, but I'm very curious about a lot of them. There is a ton of animal data on BPC 157, so much interest in BPC 157, very little, if any, human data. That worries me, but what worries me more is that BPC 157 appears to be angiogenic, meaning it grows blood vessels, and that can be great, or it can be problematic depending on what those vessels are feeding. I'm not saying BPC 157 is bad. I'm just saying this is my kind of caution about it, and I hope to, and I will have. I have a calf injury on one leg that is due to some nerve damage from a skateboarding injury, repeated skateboarding injury years ago. I was trying to bring that back. And actually it's amazing. I was injecting it directly into the calf for a couple of weeks, and I actually found I could, and longer actually, it was a couple months by the time I finished because I was doing it infrequently. And I found I actually was able to finally contract that calf meaningfully while running and through weight workouts in a way that brought some of it back, but it was pretty badly atrophied. But I've been doing other things to try and get the tissue generating again, or I should say the neural activation of that calf. It's not a structural issue that I was born with. It's injury induced, and it feels much better. But I'm currently not taking BPC 157, and I'm worried about prolonged use. That's my concern. Prolonged use. But and then some of the other peptides like sermorelin, tesamorelin, the so-called growth hormone secretagogues that stimulate growth hormone release. I'm not on growth hormone. My concern about sermorelin was that I would take it. I took it for infrequently over a period of time, and I noticed that my sleep, I got a lot more deep sleep as measured by my 8 sleep, but that it obliterated my rapid eye movement sleep, like completely gone. And then so I stopped taking sermorelin, but I wasn't taking it for that long or that frequently. So what I found for me is that, the core set of supplements plus training right, plus life, lived in the way I described, some hydration, et cetera, that seems to work best. And what's my measure of that is feelings of vigor, whether or not I can recover from my workouts, meaning am I getting any progress in terms of loads or other intensity variables or distance or speed over time with the cardiovascular stuff. And the answer is yes, small improvements over time are really what I'm after, or maintaining what I've got. Because at 48, I'm just interested in staying healthy, and sure, would love to be even healthier, but I'm also paying attention to how much cognitive vigor I have. If I'm training so much or paying so much attention to nutrition that I can't engage in work and function, that's not good. If I can't sit for 3 hours and have a conversation because I'm in pain, that's not good. And fortunately, I've got things in a place where I feel generally good, sometimes great, but good most of the time. I still get bad nights sleep every once in a while. I still stress. I don't tend to do cheat days or things like that. I love the occasional piece of pizza or croissant or something like that. But I've also learned that most of the things about taking great care from nutrition, lifestyle, mindset, and the rest creates a kind of a heightened sensory experience of life. This is what I think people miss. They think of it as deprivation, but when you're doing these things and you do them consistently, I find at least that, first of all, I love the foods I eat. I love meat, fish, chicken, eggs, vegetables, certain starches, fruit, etc. That I enjoy all of those things, and I also enjoy all of life so much more. Whereas I find that things, for me anyway, alcohol, highly processed foods, they create a kind of cloak over my senses. I don't enjoy life as much. But of course, a really good cookie, or sure, that makes sense, and I enjoy those. So I look at things as all of it: exercise, nutrition, supplementation, any kind of NSDR, things like that. As do they allow me to lean into life with more vigor, with more curiosity, with more texture, or do they kind of consume a lot of time and don't allow me to do that? And in my experience, the things that I described, and there are a few others that I do, allow me to live life better, right? It's not like I'm sleeping all the time or I'm neurotically saying, okay, everybody, it's 8:30, I got to go to sleep, And look, I respect people's individual choices. I actually, the other day saw for the first time in a long time, Brian Johnson, who's, he's wholeheartedly and whole everything, devoting his entire energy to being the most measured human and longevity stuff. And that's what floats his boat. Me, I like to have some flexibility on my schedule in life. And if it costs me a few years of life, I'm willing to make that trade.
One last question. It's kind of, how do you, I'm just interested because I experience this, because we are on, we put ourselves out there, right? Mm-hmm. We're in the digital world. How do you balance the negative, the negative, parts of it, right? Like getting people being mean. It's easy for people to be mean. How do you balance that?
So to be fair, I was a professor. I'm still a professor, despite what you may say. I'm still a tenured professor at Stanford as of walking in this room anyway. I teach a few lectures in the winter, and I'll teach more in the spring starting next year. My lab has been shrunk down as a consequence of the podcast, and my interest in moving away from animal research toward human research, still involved in clinical trials, which are done remotely, mostly in collaboration with psychiatry and ophthalmology. So that was my life for the longest time, plus the lab life, and people running experiments. And I was just a very private person. Then 2019 started posting on Instagram, 2020 started going on podcasts. 2021 launched the podcast. In 3 years, it's I'm quite grateful for this, but it's grown a lot, and I'm, humbled and honored. Like truly, it's such an incredible honor and privilege to be able to teach to so many people and to get the feedback. The negative stuff comes in a couple different forms. Some are negative comments and news articles that are really in the form of the comments. I think people working out their stuff. I don't know if they're drinking, they're angry, they're dealing with a psychotic issue, or they maybe are just kind of having fun, or they're angry because there's a misunderstanding. In terms of press, as the podcast has grown, our name, my name, and face have become a source for generating, clicks in response to things that contrast with people's preconceived notions of what I might be about. So I understand that relationship. When you put yourself out there, you make yourself subject to that. As your popularity increases, the potency of attacks as a source of clicks increases. I also look at it as much as I can through the lens of not just how it makes me feel, but like what's meaningful in coming back here that I can pay attention to and might want to adjust my delivery of information or anything else in life too. It gets frustrating when it's personal. I think that, I'm not going to beat around the bush here. I think, there have been some personal attacks that have been quite public. And I've talked about those. I talked about those a little bit on a Jocko Willink podcast recently. I can summarize it, pretty simply by saying, I'm of the mind that personal matters should be settled personally and not publicly. I also just really believe in trying to have those conversations privately, because both people understand context. In articles, context is lost. I also worry not so much about direct or indirect interpretation of things as much as kind of like certain narratives getting exported and kind of like the runaway train of those. And I will just kind of leave it at that and just say that, obviously I, like everybody else, is flawed. I struggle in certain ways. I have certain things I'm better at and worse at. I'm always striving to be the best version of myself I can be, and to try and, do that on a personal basis when it's personal, and when it's public in terms of relationship with the public, to, communicate as much as possible without, just trying to convince people, but hey, that I'm here to try and learn, organize, and distribute information that I think is really useful to people. They can take it or leave it. I really do that. It is a labor of love. I really do love doing it. And I know that I can't do it perfectly. I certainly have made mistakes. We correct those in the show note captions. People definitely point them out. It's always embarrassing. It hurts. And yet I try and just take it, say, okay, what can I learn from this? In my private life, make those adjustments as best I can. In my public life, make those adjustments as best I can. I published a correction recently on, by saying, hey, I made a math error in this thing. It was actually, I made a joke about it in the episode that didn't make clear that there was it didn't make clear or clarify the misunderstanding. So in any case, just said, okay, here's the deal. Here's what we do. I guess the short answer is, I like to think there's always learning there. Take the Jocko Willink, like good, mindset of, okay, good. Given that it happened, you say, good, what can I learn from it? Move on. I think a big part of being an adult and being a human being is learning when to stand one's ground and say, okay, you feel that way, I feel this way, we're going to agree to disagree. That wasn't that way, or I feel differently, okay. But the other half of being an adult is saying, I could have done better there, or wow, I screwed up, and apologizing, or making the effort to remedy it going forward. And it's always hard to know exactly where that is. I have been saying one thing in particular lately, which no clinician has challenged me on yet, which is that when I go online, I generally assume, especially social media, that I'm dealing with essentially a borderline organism. Borderline is not bipolar. Okay, borderline is, the classic definition is weaving back and forth between a healthy mind and psychotic. A borderline person splits by telling you at one moment they love you, they adore you, and then at the next moment that they hate you and all the reasons why. And I look at engaging on social media like engaging with a borderline person. So I now expect that when I go there. And I could go on and on, but what I'll say is, this stuff thickens your skin. The good stuff feels good, the bad stuff feels bad, and then over time it all kind of neutralizes. And I'm also blessed to have a great team around me to help me with optics and clarity, and I have great people in my life. And but it's not fun all the time. And there are days where you go, hey, I'm trying to help people. I'm out there trying to do this, and don't they see it's not about supplements, it's about these behaviors, and the supplements help, but they're not the focus, or I'm not all about the cold plunges, or, there's always this desire to try and explain oneself, and that never works. So I've decided I'm here, I'm doing this. I know I'm doing it with the real intention of trying to give people the best information at zero cost that I possibly can. I'm human, I'm going to make mistakes. I will adjust as best I can going forward, and people also have the opportunity to tune out or tune off, and live and let live is my philosophy. My graduate advisor, Barbara Chapman, used to say, listen, tolerance has to go in both directions. So never easy for the hard stuff, very gratifying for the positive stuff. One of the best sources of feedback I receive when people say, I can't believe this is free, like you're giving us this information. I'm like, yeah, and I love doing it. So that fills me, and plan to keep going.
It's very clear. I mean, it's very clear you love doing it. And I've certainly learned a lot from you, and, especially on a lot of the topics that we talked about today, where I was really diving deep. People can find you, of course, on YouTube, Huberman Lab podcast, on Spotify, Apple Podcasts, everywhere. Social
we're
media.
Around. Huberman Lab, we're around.
Twitter,
there wasn't
Instagram.
one of those. Yeah, it's been a lot of fun, and we've got some stuff planned, some shorter format episodes, audio only. The AI stuff is starting to build out, but the core of it is learning and organizing and distributing information. More great guests. Please come back on the podcast.
Oh, please.
We have so much more to cover.
Let's do it. I know. I was
more solo episodes for sure.
Gosh.
And again, I want to make sure that I say this again, as I did at the beginning. You're a true pioneer in this area. You went first in. The bravery associated with that is immense. I know that as an academic like you, and you've persisted in really pushing hard to deliver the best information with the most amount of rigor, even touching into some areas that there's not, let's just call them what they are. There's some controversial areas. You just pushed really hard into this, revising things as necessary as you go and more data come out. And I just love what you're doing. I consider you a real colleague and a friend.
Well, thank you, Andrew. Likewise. And it's been a real pleasure. Would love to talk to you again soon. Let's do it again for sure. Thank you for everything.
Thank you.